works.
It works. Cool tech.
Hello, everyone. Sorry for delay. And thank you very much for attending our first PostgreSQL charity workshop here in Warsaw. We are extremely happy that you are all here. Thank you for all your donations that you have made. Thank you. And we are really grateful to see some Ukrainian faces in here. Personally, me as Ukrainian by origin also. My name is Anastasia and I'm the sales and marketing manager at Polish branch of Cybertech family. We really hope that you will enjoy our workshop, that you will get some valuable knowledge, and of course that you will have some fun with us. We are prepared for great networking with beer, pizza, and so on. And let me introduce our first speaker. This is our beloved CEO, Hans-Jürgen Schönig, PostgreSQL expert for more than 25 years. Well, for almost, I don't know, half of his entire life. He has prepared a marvelous talk about PostgreSQL performance. So I think that's all from, no, it's not all. Some organizational moments. We will have 2 short breaks, 1 lunch break and a networking afterwards. The event is planned till about 6 p.m. So yeah, that's it. Have a great time, and Hans, the stage is yours.
Hello. So thank you for a couple of folks showing up here to this event. Actually, I've been to the Ukraine a couple of times, so I know the place, right? So it's not just we're doing some strange event here, capitalizing on war. I've actually been there a couple of times, and I know many people there. And we actually had people being woken up by gunfire when the war started, right? So, as I don't like it too much when somebody shoots at my workmates, we decided to do this event here, and yeah, let's see if something useful comes out of it at the end of the day. You know, hopefully you got a good time. Hopefully you learn something, and well, hopefully something happens to the better. And again, it's personal if people shoot at my employees. We don't like that too much. It's kind of sucks. First topic of the day is Postgres performance in 5 minutes. I refurbished this kind of stuff some time ago, but I think what you're about to hear here is something like, I would say, everlasting truth. This presentation is going to outlive me by 200 years, right? So this is eternal truth, right? This is going to be longer than gravity, right? So people will fuck up the databases long after gravity has been disproven, right? So this is certainly going to be the case. So short introduction, we're quite international, including Poland. We got some cool stuff here. We got a couple of cool customers. Everybody's happy. So where did we actually get the inspiration for this kind of thing? Let me just quickly outline how that happened. I remember there was a customer in Germany, and they wanted to purchase some nice Oracle system, you know, Oracle Exadata and the IBM equivalent, and some really, really fancy thing to the tune of 4 million euros. So how much is that in cruise missiles? I don't know. But actually, we're talking about 4 million euros, right? And what we basically found here was that we're talking, they had 330 billion rows in the database, which is basically the entire maintenance history of the whole bloody company, right? So every product they ship, maintenance history, everything, right? The whole thing, 340 billion rows. And for some reason, Oracle didn't like that anymore. And that is not a problem in Oracle. The problem is if your query is select count star from 340 billion, where not in subselect 8 billion, everybody will die, right? So if you do 330 billion minus 8 billion, that's not going to work out brilliantly. So they had something like 20 queries identified that would cost this investment. And me as a Postgres consultant, I just had them at the dinner table, right? And said, well, let me see, just show me what you're doing. And they showed me their queries, which triggered an investment of 4 million euros. And the bottom line, nobody knew what those things were doing, right? So you're spending 4 million euros on queries which have no clue what they're good for. It's not like we have this problem, we want to solve it, right? We've got the money to do it. No, that 300 billion rows, total insanity, no aggregation, nothing. And bottom line, nobody even knew what the shit was doing, right? So that's a very good inspiration for failure. And if you want somebody to fail, I highly recommend you to follow this approach. Don't know what you do it on a lot of data, do it inefficiently and spend money on that, right? Throwing hardware at the problem only makes sense if the problem is human, right? So then throwing hardware at the problem is totally okay. If you're throwing hardware at the technical problem, it usually isn't. So only use brute force on people doing that. There is also some other guideline you can follow to make things blow up badly. Let's go back to those 340 billion rows and try to join them 14 times. And for some reason, this is going to fail. And that's predictable, okay? Again, that's the only thing in the world that unites mankind. This kind of failure happens from the North Pole to the South Pole, from Germany to Africa, everywhere. So this really unites mankind more than anything else. Right? Nothing is as strong as this type of fuck-up. It's completely international, seen it everywhere, same excuses, right? Excuse could be, this query has been generated. That, of course, is an excuse for being bad, right? This was written by somebody else. What is it doing actually? It should not be that way. It's all international. So this works in more languages than Coca-Cola, right? It's absolutely international thing to do. The bottom line here is that if you're working on a small data set, and small could be a couple of million rows, couple of thousand rows, 100 tables with 10 rows each, you can basically do what you want, right? So if you have 100 tables with no content, do what you want, no problem whatsoever. Hardware is going to fix that. And if you do things on a lot of data, the more data you got, the more dangerous things are going to become. If you have 100 terabytes of data, there is no such thing as the database abstraction layer is going to take care. So the more data you got, the more you have to be aware of what you're doing, right? If you have 100 tables, no data, do what you want, right? It doesn't matter. But if you have 100 tables with data, I mean serious data, then this is a recipe for disaster. And can you tune Postgres? I can offer you a secret, and the secret is there is no such thing as performance on, right? PostgreSQL parameter that says performance on doesn't exist. And if this parameter would be there, let's assume this parameter existed, what would be the default value? Just, right? Oh, of course, right? Because somebody in the Postgres community sits there and says, performance off because you bastards will all hire consultants, which is turning on this secret parameter nobody knows about, That's how it works, right? So, no, it doesn't. Actually, there is no such thing as performance on, at least not because somebody turned it off because he's just an evil bastard, That's not the case. So the solution to the problem is usually not some crazy thing. And also people try to do hallucinations. They like that. I think if we add more disks, it's going to be miraculous. My friend, I just have to admit briefly that you got 100% cache hit rate, you got a terabyte of memory, 5 gigabytes of data, and you don't write to the database. can you please explain to a humble Postgres consultant how much faster you're going to be if you add more disks to the systems which are not used anyway? Just asking. No. And usually there is no answer. We thought because we read somewhere more disks, more performance. I had one case in Germany. For some reason, all the evil comes from Germany. Sorry. No, when the Russians catch up. They had a terabyte of memory. Terabyte. That's a lot. 90 CPU cores or something like that to handle a university with 2,000 students. And they ran into a performance problem. How cool is that? And they asked me if hardware is sufficient. You've got 20 gigabytes of data, 1 terabyte of memory. What do you think is going to happen if you add more memory? Do you think managing empty memory is going to improve performance significantly? No, the problem is usually the application and hallucination, meaning if we add more disks, then surely things might change, is the most important thing. It's like my car is not fast, but maybe if I add more petrol, maybe miraculously things are going to change. That's not the case. So we need a bigger server, might compensate for different problems. We need more disks to be faster. We need more RAM. I mean, no database guy is going to complain about more disk and more memory, don't get me wrong. But this does not make anybody happy unless you're Intel, AMD, somebody like that, you know, disk makers, stuff. Usually the problem is different. And let's see what it is. So the first thing you want is, instead of just blindly fixing stuff, you might want to do what a doctor is supposed to do. Is not just to check the symptoms, but check the root cause, right? If your database is slow, there is one reason, exactly one reason. It's not the cache hit rate. It's not your CPU count. It's not some crazy metric. There is one root cause only, queries. So why does everybody look at the bloody cache hit rate and does not look at queries? Why is that? No, nobody looks at the fucking queries. They all look at network throughput and database cache hit rate, and database size, and users, whatever. Just look at the fucking queries, right? Just look at those queries. That's the answer, you know. And then they say, oh, a query is the root cause of a database problem. You must be genius, you know. It's like that. You know, we need a bigger server to store this information that the query is the problem, right? How cool is that? I love it, you know. And this is totally international. That works for Hindus, atheists, Greek Orthodox, I believe, Armenian, Greek. You know, all kinds of stuff. But it's wonderful, right? It works for everybody. So get the bloody measurements and don't get the bloody measurements for irrelevant stuff, right? If somebody, and I have this discussion every day, not with this guy, he behaves, but usually with other people, right? You see somebody lying on the floor. He has a hole in his head. There's blood coming out of it. There's a gun next to the guy. And you say, maybe he was shot. And they say, let's check his speeding tickets first. I said, I can see, there is proof, right? He's dead, he's a gun in his head, you know, he has been shot. Oh, let's consider all the options first. Right? You literally have this discussion and it never leads anywhere. So eternal proof is, here is the problem. Forget the shitty graphs, look at the bloody queries, you know, that's the answer. And there is one way to do that. Log files are nice, but log files are, you check every query. But what you do want is aggregate information. This type of query got executed 1,000,000 times. I can assure you, if you execute something that takes 1 millisecond 1,000,000 times, it takes more time than running one thing that takes 5 seconds. Sometimes it's not the slow queries that blow you up. Sometimes it's those millions of tiny queries that are the issue. Okay, forget the slow query load. If you have an application that looks up things in the phone book, there is no slow query. I mean, there is one. It's called backup, loading, reindex, stuff like that. But that's not your problem. If you click on the button, it's not the reindex that blows you up. Okay, so look at the bloody statistics. Look at query. And PostgreSQL statements is the single most important thing providing relevance in the world. So if you want to really understand what's going on in a database, just enable the damn thing, you know, always. Overhead is close to 0. Overhead is noise, so it's something like noise. We're talking about 0.5%, something like that. And the answer is, oh, we sacrifice 0.5% to figure out what's going on there. I can assure you, if your application does not work because you're sacrificing 0.5% of performance, you get a totally different problem. And it's not a technical one, it's a mental one. Okay, just to make sure. So always make this investment, forget the log file part, forget it. Just forget it, right? So that's PostgreSQL statements. What it gives you is queries. And what it does is it basically collects information about types of queries. So if you got select star from phone book where name equals Pavlo, Patrick, Michał, it's all the same query. It's common, right? So it's where name equals $1. So it takes the same types of queries and compiles that. And there is something really, really cool here. It's called total execution time. This type of query was called 10 million times, and in total, it took 17 hours. And there's the secret. If you order by total execution time descending, you will get your root cause. Because the thing that needs most of the time on your machine is most likely going to be the problem, regardless of cache hit rate. High execution time in aggregate is a big problem, and it needs a totally overpaid consultant to figure that out. And that's international. Works very well. Perfect. Infinite business. Min exec time, max exec time, whatever. So this is also relevant. So you can figure out, okay, this query in average is 1 millisecond. It was executed 1 million times, but for some reason, they are not all created equal. So it could be the case that average access time is totally fine, but there are spikes. Let me give you one example. Input matters. I was in Tunisia before the revolution. So I went into Tunisia 2 months before the revolution. I went into Thailand 2 weeks before the tsunami. I went into Warsaw 2 weeks before. Let's get it. I was in Ukraine 3 months before, whatever. So just get out of Warsaw. And there I was sitting with 8 people in the training course. I did a training course in Tunisia, 8 people. 7 boys, 1 woman. 2 people speaking English, the rest only speaking French, and the argument was they will pick up. I mean, it's like talking to, you know, Chinese, right? Just watching it, right? Anyway, so out of those 8 people, 6 people were called Mohammed. If you go to Cairo, and if you want 2 million people to open the window, go on the main square and say Mohammed, right? And you will have 2 million people looking at you, right? So obviously there is a difference between where name equals Mohammed and name equals some fancy Jewish name, right? In Cairo, right? So the input parameter does matter. So it could be the same type of query, but depending on what you feed, you will get totally different runtimes, right? Where name equals Hans in China is most likely not a problem. Where name equals Chang in China might be half the population, right? Or where language is Tibet, it brings you everybody who's in jail or something. And then comes the cache hit rates. So for every bloody query, for every type of query, you can get cache hit rate. And that's super cool because the overall cache hit rate on the database is irrelevant. We had a support case at night, the cache hit rates drop. What happened? Every night. And the answer is your backup. Right? If you're reading all the data all the same time, you're reading the identical data all day long, right? Addresses, stuff like that, cache hit rates, super. At night, they drop. It's a miracle. Yeah, because some job just reads all the data. And you got 10 gigabytes of memory, 1 terabyte of data. Guess what's going to happen? And to make things really, really blown up, you hire folks from India. And trust me, this is like HIV. You never get rid of it. You tell them at night, the backup reduces cache hit rates, and that's supposed to happen. And then they come back with cache hit rate should be at least 80%. Yeah, cool, yeah. But this is still the nightly backup. 3 weeks later, the answer is going to be, but the problem is still there. Yes, it's going to stay there. And six weeks later, management is going to call you, and this happened. And they say, there is a support ticket open for 6 weeks because of why does nobody care? Well, we do care, we can fix it. That's supposed to happen, right? There is no way to operate without a brain. There is, but it's not satisfactory. Okay? And this has to be seen in the context of a query, a cache hit rate in a data warehouse. 0 is fine, okay? You have 10 terabytes of data. It doesn't matter how much RAM you got, cache hit rates are going to be irrelevant, okay? If you do the same thing in the live system, it's not. Cache hit rates have to be seen in the context of a query, always. Overall cache hit rates is for painting walls, making management happy, making idiots happy, making idiots unhappy, doesn't matter. But if you really want to extract relevance, it's a context thing. Next thing is I/O time. Always turn it on. One of my workmates implemented that some years ago so that we can distinguish CPU or anything that is not I/O related from I/O. If the question is, and I think you've heard that before today, if we add 10 more disks, is my system going to be larger? The cool solution to the problem is figure out how much time you spend on I/O. How cool is that? And that's the way to do that. So if you turn it on, you can actually see this query might be faster and this query might stay the same because it does not use I/O at all. See, you want to pinpoint the problem. It's always a query thing. It's not a global thing. And this is literally the 1 million whatever currency query. 1 million ruble query. So forget the substring. I'm only doing that to make it fit on the screen, right? So forget the substring part. That's just for fancy thing. What you want here is give me the total execution time of this type of query. Tell me how often it was executed. Tell me how long it took in average. And this here is the percentage of total time. It's magic. And here is the 1 million query line, 1 million euro line. It says order by total time descending. And there is one cool thing here. The second query in this listing can never be more than 50% of the problem by mathematical design. And the 10th entry, trust me on that one, is never going to be more than 10% of the problem. Always, by law, okay? And even there you can fuck up. It works. I had this output, and here it says this thing here, 55%, this thing here, 42%. somebody saw this listing, I mean, not this one, but this type of listing, pointed at the query down here, 1.16%. I remember it if it was yesterday, not Alzheimer's style, but really. And he said, I knew this insert was the problem. Buffer overflow, right? Syntax error, what the fuck, right? So you're pointing at 1.16% and the guy tells you, I knew this insert was the problem. No, it's not. This is your problem. If you could just eliminate this query, not even by tuning it, by just eliminating it, because for some reason you can fix the application if you don't need it. You double speed, right? How cool is that? So that's the point. And this is also an issue. What's the slowest query here? It's a copy statement that was executed once to load the data, and it's 0.09 seconds. That's the only query you could have found in the slow query log. And you can most likely not get rid of loading your data in the first place, can you? Just thinking. Crazy conspiracy. Okay? So next problem is, this is always going to be 100% by law. Okay? How much faster do you think this query could be? Just ask. It's 1 millisecond. So maybe we can get it down to 0.9 with clever fill factor, whatever. But if you see that this was called a million times, it might be the worst thing in the system, but at some point you can't fix that. So there is no way around a human judging that this should be a second or this should be a millisecond. You have somehow have to figure out on your own. Okay? It's magic. Yes, sir.
I think that without data, your database will work really fast.
Yes.
That maybe this is the reason for performance issue.
Yes, and the point is, I'm a bloody good Postgres consultant. And I'm controlling the content. That's even cooler. I'm only showing you cool stuff here. And this is also really, really cool. Indexing. I ran this benchmark on a training machine last week. It gave me 34,000 transactions per second. If you drop one index, it goes down to 3 transactions per second. One index, 1. Okay? The argument that indexing is always right is the same as I almost missed when I tried to shoot you. That means dead. Okay? There is no such thing as almost not pregnant. Doesn't work this way. So one strategically wrong index can blow up the whole thing. And as my beloved colleague keeps saying, how was your day? And he usually asks me, how was your day? Missing index or real consulting? And that's what it is. So missing index or real consulting, because indexing is 70% of all performance problems. How is that? When an application comes into existence, there is missing index, and you add an index and it fixes stuff, and it happens again and you add an index and it fixes stuff, right? After making this thing 3 or 4 times, everybody understood that indexes are the solution to all problems of mankind. So they keep adding indexes even if it doesn't help anymore, right? So an application usually goes from under-indexing to perfection to over-indexing. And you end up in the same sheet, right? Okay, so that's what happens. But it's really 70%, and this is funding my winter holiday every year. Missing indexes are perfect because they fund my vacation with 100% reliability, almost. That's how it works. So if you approach a performance problem always check for missing indexes first. Missing indexes first, regardless of what they're telling you. It's like going to the doctor. You got a headache. And you go to the doctor, and it has to be, if you have a headache, in order to have, you go to the doctor, I have a headache. It has to be at least brain cancer, right? It has to be something sophisticated. You don't go to the doctor and they say, well, just don't drink in the evening. Hangover is gone in the morning. I mean, what an idiot. It has to be at least brain cancer, right? It is the same as with database performance. It has to be at least the kernel level rate driver firmware update. No, it's just a fucked up query with a missing index in a stupid application. Oh, okay. The fact that it's a super fancy corner case thing is very rare. Unfortunately, because otherwise my job would be much more interesting, right? But it's usually, it isn't. So it's at least 70%. So the question is, how do we figure out? And we're looking for expensive stuff that happens often. Must be a genius. And that's how we do it. That's the 1 million euro query. Bloody table. How often did we read this table sequentially? So often did we read the table sequentially? How many rows did we find? And trust me, if you read a table with 100 million entries 100 million times, you're going to read 100 million times 100 million rows, and you will notice. Reading 100 million rows 100 million times is more expensive than reading 100 million times one row. How cool is that? And it's not a 10% improvement, it's 100 million times improvement. How cool is that? You cannot fix that with hardware. You cannot buy hardware that's 100 million times faster. But you can have a database developer or database consultant or anybody with the concept of a brain to figure out that that's the case. So try to avoid that. So, and that's what we're doing. What we're saying here is, tell me which table was processing most tuples. So if you do something 100 million times on a large table, this number is going to be mind-blowing. We've seen 15-digit numbers, 14-digit numbers. And if you have a 14-digit numbers of rows thrown through your CPU, you will notice. This is how you identify the tables with a missing index. So I can assure you, if that's the case, you will see that if we just got statements. And often hardware is hiding the problem. You press a button, it takes 200 milliseconds. Select count star on 10 million rows can be in 250 milliseconds. With enough CPU cores, enough whatever, you press a button, 250 milliseconds is not enough to make a customer complain usually. Because they're used to suffering. They've been in IT for many years. They're used to suffering. It's like infinite damnation, right? But your system will notice because 250 milliseconds means 4 queries per second. 4. The same system could do 400,000 per second if properly indexed. The question is just how many users do you have? Okay, so check for missing indexes. That's the solution to all problems of mankind. So it usually correlates, and this is actually worse. Imagine you have one customer and one row. And one customer logs into your system once a day, he reads one row. How many rows did you read? One row. But suppose we got 1,000 customers that read 1,000 rows, log into the system once a day. You already read 1,000,000 rows. Then you got 1,000,000 customers that 6 scan because there is no index, and 1,000,000 customers log in once a day and to read 1,000,000 rows. This squares out. A single sequential scan is twice as much data, twice the runtime. But if twice as many people read twice as much data, it squares out. It's 4 times the effort. So this is why missing index often customers say, this used to work for 5 years, no problem. But for 2 months, everything went nuts, right? Yeah, because you got 20% more customers, which means 20% more people log into the system to read 20% more data means 1.5 times the effort. And that kicked you over the edge. In reality, it's not linear, it's squares. Seen that often, all over again. Database is growing and load is going up squared for exactly that reason. Usually it's 1, 2, 3, 4, 5 missing indexes, right? The potential solution, great index. How cool is that? And that's like gravity. It's gravity, right? Gravity is going to go away long before this problem goes away. So there are 2 things that are going to survive atomic wars: cockroaches, bureaucrats, and missing indexes. Okay? I'm not sure who is going to die first, the bureaucrats or the cockroaches, but this is going to outlast, okay? Certainly. The missing index is going to sit there, just long before, after the bureaucrat has died. There was one bureaucrat in Finland, a tax collector, who died, and they figured out after a couple of days, because they thought he was sleeping on his desk. That's fine, but he was dead. Okay. There is a media post on that. It's credible. I've seen those people. They just were not dead yet. So, okay. So let's suppose we have an old database. Obviously, it's 2 genders only. So male, female. Yeah, that was God's punishment for being politically incorrect. Obviously. Oh, okay. So let me try to fix that. Yeah, you shouldn't do politically incorrect jokes. The universe is going to have revenge itself. So, are you fixing stuff, Michał? Probably. How about likely? Okay, let me entertain you while we're going through this miserable technical problem here. It seems that it is. Are you always blaming me? I don't know. So let's try to turn it off and on again.
I can replace with you and have type C.
Ah, we made it. See, everything is fine.
It's because you've raised up and sit down.
I think this stuff gets scared when a real technician comes. This always works, and then the consultant comes in and the whole thing just shits in his pants. I've seen this all over again. So there are. What if we don't move? Ah, that's something.
Super special effects.
Yes. It's on purpose.
It's a missing index.
Oh, sorry. Yeah, it's not a missing index. It's missing life. Go away. I don't want what's up to be here. Go away. And I want my mouse to be back.
You have to try to turn it off and on again.
It didn't want to turn on in the first place.
At least 3 times.
Oh, it's fine. Let's change resolution here. Maybe it's just the Russians listening in, but then it wouldn't work at all. So, yeah, it sucks. Let's try to change the resolution here and see what happens. Yeah, it's a lot better. yeah, we're soon done anyway. Sorry for that. It's not my fault, but I don't know who to blame either. So anyway, so we got a second table here that's called, come on. Let's try it with like this, doesn't matter. That sucks. Let's try Michal's block. This is really big. No, so you do this one. Let's try to plug it into the other side because maybe it works miracles.
We can come closer to your laptop.
It doesn't stop the flickering.
We'll just show how things.
And now the end is near. How cool is that? Apparently it works. Thank you, sir, for your service. So we got two tables here. One is gender, 2 entries, and the other one is person. And what we got here is obviously the ID. So after I've shown you how miserable things are in the real world, let's show you something. It is something how to fix that, right? We are generating 5 million entries. Generate series is a Postgres consultant stream because if the customer does not have data, we can make it. Right? So from generate series means give me a list 1, 2, 3, 4, 5, all the way up to 5 million. So we can scale it. Just have to add more digits and scale it. So and then we say 50% men, 50% women, some data. Right? Just so we have 2 genders and 5 million entries. And what we want to do here is select name, count star from gender, people, blah, 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 group by. So we want to count how many boys, how many girls. It's that simple. And what you can see on my machine, we're talking about 961 milliseconds. So the question is, can we do better? And the answer is yes, we can. We can do the whole damn thing in 500 milliseconds. And the answer is buried deep inside the Postgres optimizer. In fact, one of my colleagues has already written a patch for that, which was not reviewed by the Postgres community for 5 years, because I think there are only 5 people in the world who can read that. Tony, yeah. So what we do here is we could say, okay, what's the problem? 5 million people have a gender ID, but what we do is we count gender names. Postgres has to join first, aggregate later. It means that for 5 million people, we have to do a lookup of the gender ID to resolve it to gender name and then aggregate. And the optimizer has to do that because 2 gender IDs might be associated to the same gender name, right? So doing the automatic transformation is hard. So if we aggregate by gender ID first, we don't have to do 5 million lookups. We don't have to do any lookup because it's gender ID. And then we can join the whole thing with gender, but the result is only 2 gender IDs. So we aggregate on gender ID and then to 2 lookups instead of 5 million lookups, right? And then we double the speed. Okay, that's how it works. Any questions? See, you can fix stuff. It's not like it's always missing index, so you can fix stuff at some point. It's a miracle, has to be. So that's the execution plan of the first thing. So we read gender, 2 entries, then we read person, we have to join it, and then happens the aggregation. So the problem is we got 5 million lookups here in the hash, and that's going to blow up speed. Do the same thing like this. The execution plan says, okay, let's aggregate those 5 million rows and then join 2 rows. And that's where the speed is coming from. Right? So there is a way to fix stuff by looking at queries. There is a way, but notice we did not change a single memory parameter, not a single storage parameter. We changed nothing. We never thought about memory. We never thought about table spaces. We never thought about max connections. We never thought about work mem, whatever, right? Nothing. We double speed, but just understanding what the data system does. Okay, not memory related, not CPU memory rate controller level, cache hit rate, whatever related, nothing. Just understanding what the data thing does. Okay. Lessons learned. Well, we simply know how it works, right? So one more classical example where you can fix stuff by understanding. Let's suppose we've got a couple millions of data, sensor data, like measurements, like sensor number 1, temperatures, whatever. And what we do here is refurbishing old slides. Imagine you have a piece of data, and every year you get 1 billion entries. So after 20 years, you've got 20 billion entries. And what we're doing here, we just want to know for each sensor, how many entries did we have in this year. Simple. So what we're doing is 1 billion out of 20 billion. And in Postgres, the problem is, if you have a standard index, it's roughly 25 bytes per entry. So if you got a table with 1 billion rows, the index is going to be 25 billion, right? So this leaves us with 20 billion times 25. So the index alone is 500 gig. That's relevant. Okay, index alone is 500 gig. That's relevant. Which means if you read it, it's random IO. Can we fix it by adding more disks? Usually not, because the reader has a problem with disks. Okay. So how can we fix it? And the answer is a block range index. If we got sensor data and time series, they have a very nice attribute. Yesterday is not going to come again. Could be a good thing, could be a bad thing. So time is usually going up, usually. I mean, daylight saving and time server synchronization, but in average, time goes up. Which means that if you got a table, it's sequential. So it's kind of ordered. If you insert time series, it's kind of ordered. It keeps growing. It goes up, right? It's very unlikely that tomorrow is going to be 2019. Not very likely. That's an intrinsic attribute of time series. So what we can do here is, instead of having a B tree, we can use a Brin index. And what the Brin index does, it takes 1 megabyte of data, calculates the minimum and the maximum. Takes the next megabyte of data, minimum, maximum. Next megabyte of data, minimum, maximum. That's cool, because 1 megabyte of data could be thousands and thousands and thousands of rows. But if you want to store the min and the max, it's just 2 entries, right? So this thing here, this block range index, is really, really small. So instead of 100 megabytes here, we got, or 500 gigabytes or whatever, it's 48 kilobytes. It's thousands of times smaller. But it only works if your data is sorted, which means time series, invoice numbers, whatever, right? So you should make damn sure that the thing is sorted, because otherwise it doesn't work, right? Because min, max, min, max, min, max. And if it's not sorted, the min and the max is everything, right? So that's what it is. And this is going to speed up things dramatically. So that's a data warehousing thing. So indexes are the solution to many problems, but in Postgres, we got many types of indexes: B-tree, hash, gin, gist, SPGist, Brin, those are the built-in ones. Then we got Bloom filters, then we got RAM, Wordcut, Z-curve, and I've got one more. So if my counting is correct with all the extensions and stuff like that, Postgres has, I think, 11 types of indexes for different purposes. Okay. So that's what it is. So this is big, but you need sorted data, otherwise it blows up. Okay. So pre-network, that's how it works. You can fix that. Yeah. Finally, my grandfather always said, you're not looking for work, you're looking for income, right? If you want to work, take some stones and carry them around. Then you can work forever, but it's not going to pay anything, right? So what you want is income, not work. So one way to do that is to avoid the work part, is to do many things at once, right? So when you carry over the stone, you might want to have a second stone carried over at the same time, right? Something like that. And there are a couple of solutions how you can fix that. Option number 1, grouping sets. Option number 2, synchronized 6 scans. Option number 3, pre-aggregation. So that are the standard ways of speeding up some stuff. So here is one thing. Let's add a column to our persons table and add some random entries for age. Okay. There's actually even a way to create a distribution. So if you don't want it evenly distributed, there's actually a function in Contrib where you can make it normal distributed or whatever. So it can make it more fancy to make it nicely distributed. The table func extension is what you need. So, and let's do something like this. This is 6 queries in one, at least. We read the data once, but then we calculate the count per gender, but we also count the young ones and the old ones at the same time. So if you don't use this filter thing, it would be 3 queries. You count everybody, you count the young ones, you count the old ones. So you had 3 queries, which means if this is a terabyte of data, you have to read 3 terabytes of data, right? And then at the end of the day, we can even add the roll-up, which is the bottom line, male, female, total. So if you do that, the normal way, the ORM way, the stupid way, the I have no clue way, this would be 6 queries. So if this is a terabyte of data, it's 6 terabytes of data instead of 1 terabyte of data, right? So you can do things at once. And that's pretty cool because that's bottom line. The roll-up is going to add the bottom line, so the total. And this is a classical table you would find in the report. Total, male, female, provinces, total, right? Something like that. That's a standard table in the report. Is total, some partial aggregates, and the bottom line. Right? And that's 6 queries in one. Okay, standard case.
Can be 9.
Could be more. Right? So it could be everything. So that's one way to increase efficiency. Is just read once, use multiple times, and that's exactly what's happening here. Any questions? And yes, one more. Synchronous 6 scans. There is no slide for that. But then we quickly recap. Pre-aggregation is clear, but synchronized 6 scans. It's a very cool feature, but it's not widely known. Most people don't know that. What happens if you start this query and it takes 10 minutes? It's reading the data, right? But let's suppose a second guy is running a similar query on the same table. So when Postgres starts the sequential scan, let's suppose this is a table. When Postgres does a sequential scan, you start diving into the table, right? So your query is here. So now Taras is going to do a count star on this table. And Postgres figures out, there is one guy who's already 2 terabytes inside this table. Let's not start from the beginning. Let's start here. So we hook up, right? So we synchronize. The way we do that is Postgres periodically stores the position of a 6 scan in shared memory. So if I go through that, Postgres remembers the 6 scan, when the position of the 6 scan in shared memory. So when Taras comes in, when I'm 2 terabytes into the table, his sequential scan is going to start here. And we try to go together because it's going to be like this, right? If I'm in front, I take the arrow. But he's most likely going to find it in cache, right? So he's going to catch up. And then he overtakes me, I will catch up because I got the memory, right? We don't try to stick together whatever, but we're hooked together once. And if we're lucky, if the queries are evenly expensive, with a good chance that there's one arrow used for both of us instead of reading the stuff multiple times. Right? And at the end of the day, when I am done, he's just going to do the rest. So we are not stuck with 10 times arrow, we are stuck with 3 times arrow.
One question, you said equally expensive, but not in times of I/O, it's like in memory or CPU.
Yeah, so you do count star and I do average.
So basically the following one is counting that the data are in buffer cache already, and then he can do this whatever he can do with this.
Usually it's file system cache, because if you have, let's say you have 1 gigabyte of memory and you have 1 terabyte of data. If a sequential scan is bigger than shared buffers divided by 4, it's not going through shared buffers anymore.
Oh, so there's no
Yes.
caching on Postgres side, it's just the operating system stuff.
Yes.
But anyway, it will be much
Yes.
faster.
So if a sequential scan is bigger than a fourth of shared buffers, so if you have 1 gigabyte of shared buffers, if a sequential scan is more than 250 megabytes, it bypasses the Postgres cache. Because it assumes that, let's suppose you have 1 gigabyte of memory and a terabyte of data. What cache hit rate do you expect to happen? Nothing. Huh? If you read it all, and you have 1 gigabyte of cache and 1 terabyte of data, what cache hit do you expect? Nothing, right? It's only replacement. So the overhead of constantly replacing shit in cache, which you don't read anyway, is so high that if sequential scan is bigger than shared buffers divided by 4, it bypasses the I/O cache to avoid the overhead of replacing the pages and stuff like that. So you fully rely on the file system cache in this case. So it could happen that decreasing memory could be beneficial because you avoid some cache trashing stuff. That's true for sequential scan only. It doesn't matter for index scans and stuff like that. But sequential synchronized seq scan, it's sometimes better to just throw it up all concurrently, all at the same time, because your CPU is going to falter long after your I/O system. Because you could get, let's say, a gigabyte per second from your I/O system, but you can process hundreds of gigabytes through the CPU, right? Or tens or whatever. So maybe firing stuff concurrently can be better than doing it sequentially because of this synchronous I/O capability. Okay, synchronous system. Sorry. Cool. That was it from my side. By the way, this feature, just to relieve the Germans a bit, this is a German feature made by some Germans some years ago. Anyway, any questions? Anybody? Anywhere? Yes, sir.
In our world, yes, we have
A war or world?
world.
World. Okay.
Yes. we have a lot of data. Yes.
Yes.
And data growing constantly, exponential.
Wonderful.
Yes. Everyone knows about this. Yes. And we have new type of databases and storage, like NPP, NewSQL, databases, data warehouses. Yes.
I thought you were my friend.
And I'm really interested in your opinion on such big data frameworks and new kind of databases to really handle huge data sets.
What is huge?
For example, petabyte. Yes.
Okay. One of the answers had made good experiences with the ClickHouse engines. Because for aggregation, it doesn't have many features, but it can do good aggregation, stuff like that. But let's look into the problem and see. Yeah. By the way, before I keep forgetting, we are hiring. So if anybody wants to end up like these people over there.
I think twice.
In the special corner.
Yeah, in the basement, you know, we let them up occasionally. Yeah, any questions? Anybody? Go.
Definitely, if you are interested, not just Hans's opinion, but probably my opinion, so I can give you some opinions, very opinionated opinions about what you asked.
Yes, we are super neutral. You know.
Yes, super. Okay.
So showmaster, the stage is yours.
Thank you very much for this exciting talk
Oh,
on
I'm so
special
nervous.
events, obviously. We are a little bit after time, so let's do a really short break, like 5 minutes. Okay,
Yes, just Pavlo is taking over.
for our next speaker to prepare, so let's meet in 5 minutes.
This is first problem, so the last one to stop service. Sorry. Can you hear me? Go ahead.
Okay. So let's continue our workshop. Our next speaker is Pavlo Golub. Pavlo has arrived from Slovakia, right? Not Ukrainian by origin, as we all know, I guess. So Pavlo is our senior consultant expert more than 18 years. Also, he is a co-founder of PostgreSQL Ukraine, and he will present us and talk about his one of the passionate topics about scheduling, right?
Yeah, right.
Okay, that's it. Have fun.
Yeah, thank you. Can I want the microphone? No, I will take it. So, okay, thanks a lot to my boss that took all the time for my talk. Now I have only 20 minutes. But okay,
Half of an hour is okay.
I will skip that part where I show you a lot of marketing stuff because this guy already did, I suppose. And I will skip that part where I usually do online demo because come on. This talk will be presented in probably 2 weeks on the PostgreSQL channel led by Nikolai Samochvalov and Ilya Kosmodemyansky. So we are just like in stage of preparing the record. There I will show the whole process of building and running and testing and debugging and everything. But here I will focus mostly on what is it, what the topic of scheduling is and how we do it. So my name is Pavlo Golub. They call me senior database consultant, and that's why they give me money. But deep inside my soul, I'm just a tall and handsome programmer from Ukraine. So just okay. So this is marketing. No. Okay. So I will tell you about the different levels of the scheduling which we can apply. Then I will show the specific PostgreSQL approaches, and I will show you what tools are available, what pros and cons of these tools, and why we started our own project. Okay, this one. Why we started our own project, PG Timetable, and why this awkward name. Okay, so why anybody want to do a scheduling? A lot of tasks, and when you just start, your imagination is just like only growing. You find that you can schedule everything, starting from maintenance, import, export, ETL, whatever you want, monitoring some external actions like send emails or download something or turn the light on in the building, in the server room, or whatever you want. We usually define the three levels of the scheduling world, right? So the first one is the built-in schedulers, which means the built-in in the database system, right? Then we can use the system schedulers, of course, just like Cron or I don't know, Kubernetes scheduling solutions or whatever. They can communicate with the database server and do some stuff. And of course, I want to describe the specific projects done for PostgreSQL because, as we know, PostgreSQL doesn't have built-in scheduling facilities. So for now, only 4 of top 5, top 10, whatever database systems have these built-in schedulers: Microsoft, Oracle, MySQL, and DB2. And this is the I don't know if you can see it. This is the explanation of Alvaro here, which he did about the proposal to create a built-in scheduler into the PostgreSQL core. So there are a lot of problems, but the first and the most important is that the PostgreSQL itself was built with the extensibility in mind. That way, you don't need to put another facility into the core if you can do it outside of the core as an extension. And that's why we have, okay, so system scheduling. A lot of them, just like cron, etc. Windows has its own scheduler, cloud solution. Every of them, of course, has its own scheduling facility, Kubernetes. But the drawback of them, they can do many, but they don't know nothing about your database. They're external as much as possible. So you need to somehow tell the connection string, use some kind of automation tools, shell scripts, PSQL, whatever. So it's possible, but why should they? For a long time, we have this PG agent tool, which was the part of the pgadmin 3, probably pgadmin 3 graphical user interface tool. Later, based on that, JPG agent was implemented. J means Java. Then probably all of you know the pgcron, which is for now probably the standard de facto in the scheduling of PostgreSQL. Then pgbucket and pgautomator, and maybe more. But only four projects are still present and still maintained. So the PG agent is maintained by enterprise DB probably right now because they are doing a lot of stuff with the PG admin itself. pgcron is done by whatever. But these two are like discontinued. So the PG agent, the oldest one, it was a part of pgadmin. Of course, it's written on in the C++. There we're using VX widgets for configure for user interface, etc., etc. So the whole configuration of your tasks is done through user interface, graphical user interface, and then every information for tasks or jobs is stored in the database itself. And it can run plain SQL, or it can run shell tasks, meaning just like launch some program, take outputs and do something with that. And so the PG agent is a separate tool. It should be run on your machine or beside the server as a separate process, and will communicate with the server to execute tasks. JPG agent, it's the Java reincarnation of PG agent. This project tried to solve some limitation of PG agent, like add some built-in task like email support, make it more parallel friendly. With this tool, you can just like stop or kill your jobs, etc. And the reason that this project was started to be PG agent compatible, because at that time there were a lot of users of PG agent. It was standard de facto for that time. So to not to break this compatibility, this particular tool was written from scratch in Java to emulate the PG agent database schema. pgcron is also very, 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 very old. By the way, it's written by Citus. I remember it years. So the key difference of pgcron from other schedulers is that it's created, it's implemented as a background worker. So it runs as a Postgres server process. Of course, it's written in C, and it uses client libpq client library to open connection to the server itself and to execute some things. The drawback of the design to be a background worker is that you can only support plain SQL tasks, because since you are a background worker process, you are running as a Postgres user, and you usually probably don't have much access to the system programs, etc. So yeah, it's still very popular project, and they implemented support for Google Cloud recently, just like 3 months ago or something, and then just again became very popular on the social media. PG bucket. It's under active development, but I think that it will never see the stable release. I mean, it's a long time already, but nothing done from the time. So from cool sides for me, I must say that they are using a special configuration file, so they are storing every jobs and tasks configuration in a file, and so you can just start to provide your configuration and point it to whatever server you want, and just do it in a parallel way. The cool thing is that some cascaded events and tasks are possible. It's like we are running something like, I don't know, send email. If we fail, okay, we go this way. If we find, we will follow this way. Okay, so yeah, this one. So how schedulers approach today? We spend, I don't know, we spend a lot of time on trying to adopt pgcron to our needs, to our client needs, to be more precise. And then we found that we need some specific design decisions that we are not okay to have from the project like pgcron or pg agent. And that's why PG timetable was created. Why is that awkward name? The thing is that everything that is connected to cron is already in use. So pgcron in use, anacron cron, of course. I tried everything I can imagine to set this to cron, but no luck. Then okay. Let it be PG timetable. So the main design principles, architecture, features, no demo. Okay, the main principle, we need a 1 minute stop, meaning that it must be either the one binary to just throw it to the client and say, do your job, or it must be a Docker image where you can just say, okay, run this and you're fine. That means that if you send one binary or one Docker image, it should be non-invasive, meaning you don't need any special rights, or you don't need any fancy extensions, or you don't wait that on the server something already present. You are just like self-unpacked. You are starting, you're checking what's there and what's there. Okay, we are deploying our schema and we are ready to go. Huge number of jobs. That was the initial idea. We wanted to run zillions of them. They're supposed to be long-term, but a lot of them. So the ability to spin a million of jobs immediately is the key requirement. of course, cross-platform. Okay, and the interesting part is we wanted to divide the source of the destination of our tasks. We want, of course, to run plain SQL, but we want to run some programs that are present on our system. It may be shell, or it may be PSQL, or it may be, I don't know, CURL or whatever, just up to you. And since some tasks are critical enough to rely on the tools that are present in the system, we put them in the built-in tasks, like sending emails or logging, or I don't know. It's in built-in tasks, and we are thinking about grow this built-in tasks. Like maybe we will add soon the HTTP something, send HTTP task, where you just like ask your server if it's available, and if it's okay, you'll do something in your Postgres, or download the file, or aggregate it somehow, etc. Okay, this is the table of supported environments. It can be found on the official repository page. The fact is, it can be just replaced with one big heavy checkmark. We support everything. Just like you cannot find the system or version of PostgreSQL which cannot be supported by PG timetable. But we don't ship binaries for these ones, for these guys, because we're lazy. But they support it there. If you want, you can build it and run it. Yeah. This is the comparison table of the products now available on the market. But I would go on, I mean, for these three is the most valuable. So as you can see, PG timetable is a new product. It's only 30 years. Oh my God. So the big difference is that the PG cron is background worker, and the PG timetable, PG agent are standalone programs. There is pros and cons with both of these solutions. That's why I have a long waiting task epic of providing PG table as an extension. But it's possible, but it's like you need a month or two just like to dedicate all your time to this problem, and usually you don't have because you need to pay your bills. Okay, so yeah. So for all of them, for all major tooling, everything is stored in database. So all of them are cross-platform. Only we can operate without extension. So the PG cron is itself extension. The PG agent is not, but it has no auto-deployment of schema, as far as I know. This is the all of us, all three products can run SQL. That's good. PG cron cannot run program because it's built in the core. Only we have built-in tasks. Oops, sorry. Everyone can run jobs in parallel. Can we limit the jobs? By the way, it's an interesting feature. Yeah, in PG timetable, you can say, okay, I want this particular job, we call it chain, can run, and you can have several parallel jobs, but no more than 3, for example, or 5, or whatever, or 1. So it goes like this. So we started the job, it's working. Then, okay, it's time to start the same job, but with another parameter. The system is checking, okay, can we start it? Are we allowed? Yeah, fine. We can go with a maximum of 3 parallel chains. Okay, let's do it. Then the second, then the third started in, and when the fourth is coming, system says, okay, no, wait, we have already 3 guys running, wait for one of them or die. So it depends on the configuration. What do you want to do, to wait or to die? Okay, what else? So yeah, we can do it with the parameters. We can do it under some specific role. You can create a role without any permissions and write your jobs under that role. Or, for example, you want to have a separate roles for administration jobs and for, I don't know, for monitoring, for logging, etc. Yeah, this is what kind of scheduling you're allowed to do. Well, all you know this standard notation, like 5 or 6 stars, meaning every minute, and then you can put numbers indicating when or what. So the thing is that PG agent uses its own user interface. So you can set the scheduling only in this user interface. And when you try to do it in the database, it's absolutely inconvenient because the format is so weird that I just cannot understand what these integers mean. pgcron supports only standard cron notation. We added some more. First of all, we wanted to have interval chains, interval jobs. What that means, I'm not sure how long my job can take. Maybe 5 minutes, maybe 20, maybe an hour. But I do know that I want to run this job periodically. Then I can choose the interval notation, meaning run this job, wait for it to finish, and after that, in 10 minutes, run another one. Or I can say, run this job, and after 30 minutes, run another. It may be finished or not, I don't care. I just want to have periodical jobs. And this way, I don't care at what time of day, at what time of the night it started. I just know they are running every 30 minutes or every, I don't know. The next one is on reboot. It's useful, for example, if you are upgrading server or upgrading something or upgrading widget table, and then you restarted all the system. Okay, we have on reboot job, like archive logs or empty this table or download something, install extension, something like that. We can start jobs manually from your SQL shell, like start. We can kill them. We can set timeout for the whole job. We can set timeout for each task. So just like if job is not responsible for a minute, just throw it away and start again. And of course, we can disable jobs, meaning just like we have configuration for it, but we say just don't run, wait, we need something or we are not ready. And the funny thing here is self-destructed jobs. Just like it's one-time job. You spin it, it's executed, and then it dies. So it just eliminates information about it from the system. Probably. That's constant. This was his idea.
The idea is asynchronous execution. So suppose you got a website, you press a button and something takes 20 minutes. So you schedule a chain, it's supposed to execute once. If it fails, you restart. And if it succeeds, it does suicide because you just want to execute it once. So the idea is asynchronous execution on a website. That's the suicide joke.
Okay.
You beat it.
Okay, so we have hard times. we have hard times with the terminology because every system is calling their jobs. But we are not jobs, we are chains, because we are allowing a chain of tasks. So when I say job, I mean chain, and chain consists of tasks. Task is a simple operation like download or something, yeah. So chain means job consists of tasks. And the idea for chain is that the whole chain is executed within one transaction. So if anything happened, then everything is rolled back, but not for tasks which are using the program tasks. Like if I run something on my system and deleted the file, I cannot restore it because I have no idea what happened there. So we are responsible only for the database. So we are running everything, every task we are running within the one transaction, but we cannot roll back the task which is done on the system, the program task. By the way, we can mark. If I'm saying about transaction, we have a design decision for a task that we can ignore error of this task. I don't know, just like create table, but the table is already there, right? But if we choose to ignore that kind of error, we are still staying in the same transaction. We're just using the save point facility to check the errors and to revert to the previous save point and to be on the safe side. Okay, this is the idea. Just like this is the idea for a chain. Start transaction is done automatically for each chain. Then we want to download some data. Then we want to aggregate it to copy it to the server. Then to do some analysis. If we are fine, we want probably delete this file downloaded, and then we want to finish our chain, right? In this chain, probably the delete file might be the task, the result of which we may ignore. Oh, okay, we cannot delete it. I don't know why, but maybe next time we will download it, we'll just overwrite it and it's okay. I've said about cron styling, right? Yes, so a couple of words about logs. We have two kinds of logs. The first one is for a PG timetable session itself. So we are logging what chains we found, what the time for execution, what started, what stopped, what the current status of the tables, etc., etc. And another log is for the chain itself. So, okay, I'm chain number 4. I'm starting this task. I got result, I don't know, 200. Okay, and the output is this. I save it here, etc., etc., etc. So, for monitoring system, it's really easy to distinguish about what happened if the PG timetable itself is broken somehow, or this is just your user chain is failing constantly. And of course, you can, how to call this, join, right? Database people call this join. You can join tables, right?
Yeah, cool.
Yeah. So you can join tables and to know what exactly session of PG timetable from what host, from what time, we're doing this kind of stuff, what happened, etc., etc. Okay, so on the low level, it's written in Go, so we implemented the parallel processing with the Go routines. So The thing is that we are fine on the PG timetable side. We are limited by the database itself, because if you want to run parallel jobs, you need at least one connection for the job, because you want to be safe and stay within the transaction. You need at least one. So for regular job, if you want to run interval jobs, for each interval job, the same one database connection, then you won't have one connection to fetch the configuration, like new chains, something changed, and you want to have one more connection for logging. You cannot put them in one because it will suck and do. So, and if you have an opportunity to run PG timetable with 100 open connections, open sessions, that's fine. We can do it. We can do more. But usually, you want to start the PG timetable with the number of parallel connections limited somehow. For example, if you are not using interval connections, you want to start interval connection 0 and the parallel connection like parallel change like to 10 or 12 or something like that. Okay, so backups are easy. That's why we are saving everything to the database, including the logs. GUIs can be produced easily, but the world is cruel, and right now we have a proof of concept graphical user interface admin tool, which is not stable and not ready. And we have another, which will be part of our product Cypress, right? User interface.
Yes.
Yes. Which is not yet created and not released. But it's easy. Yeah. What else? We can ignore errors, we can do recursive protections, and we can run exclusive jobs, exclusive chains. What this means? For example, some operators like create database or throw database or I don't know, vacuum or whatever, you cannot run it within the transaction. It's forbidden. But it's a usual thing to, well, if you disable your auto vacuum, you want to run vacuum manually. And to run this, you need to block all other jobs right now, and to run only this one, so others can wait. You can do it with the concept of the exclusive execution. So the thing is that when system finds the chain which marked as execute exclusively, it waits until the stop of all other chains, other jobs. New jobs which are coming are paused and waiting as well. Then every job is done. I mean, by timeout or finish regularly in correct way. And then this exclusive chain started, executed, finished, and only after that, every pile of that chains are becoming to run again. So it's cool for maintaining, or just like run this chain at the 3 a.m. night, do something heavy. Meanwhile, every other guy will wait for it. Okay, destructive chains. This is what I was trying to tell you. Just like every chain and every task in PG timetable are very lightweight. It's just like one row describing every chain and task. So if you just spin a zillions of them, and then you can mark them as done or pause them, disable, or just delete. It's like nothing. Okay, so what else? Probably you want to monitor your PG timetable instance. For that, one can use regular PSQL or other database administration tooling, or you can try to use a specialized PG Watch solution, which has a special dashboard, not so enhanced, but still showing you number of jobs planned, number of jobs done, the number of errors from run, etc. So just like for overview, it's enough. So if you see you have errors, okay, you can go and check your logs on exactly that. Oh, that was the design. Or no, I was trying to explain to the client how the whole system should work, and that's what I come. But you know, later we have special people with special ability. So the idea is, we have our target database, right? We can run our PG timetable on the same host using some program or shell script or whatever, using some built-in tasks. So if PG timetable communicates with the database servers, like it's admin channel for getting what scheduled task to run, the information about the output of the tasks and the logs, but we can run PG timetable on a remote host. We can run 100 PG timetables on a remote host. Why not? So the principle is the same. We are talking to PG database, and we are using the same task and the same shell task. Why would we want to make that? For example, if your database host is on Linux and you want to use some specific chains or jobs on Windows, why not? Just run it on another host and you're fine. Okay, so we can have some monitoring facility. I usually have this question: can we handle several databases with the one PG timetable instance? No, we cannot. That's by design. One instance of PG timetable is serving one database, not in a cluster, one database. So for guys which has like 100 or thousands of databases on one cluster, running 100 or 1,000 of PG timetable instances is not so cool and is not really manageable. That's why the PG timetable allows you to run your SQL chains or SQL jobs remotely. So, for example, we have one PG database cluster, and for each of our 1,000 clients, we have a separate database, right? And we want to maintain this 1,000 database with one instance of PG timetable. Okay, we are creating a special database called PG timetable, for example. And we deploy this schema there, and then creating a jobs, we are specifying execute this job on this database. Like we just put there the connection string and we're fine. So next time when the PG timetable collect the chain, he reads, okay, do something, okay, connection string, bang, I'm going to this database, I execute it, but the logs, the output, everything will be collected into this PG timetable database, which is serving the instance, right? So yeah, it produces an issue with handling a lot of jobs because you need to create 1,000 jobs for each database. Not so cool, but at least you don't need to run 1,000 or 100 instances of PG timetable. Probably when we will come with the proper and good UI solution, we will make somehow this easily, like I want this job to be run on all of the database in the cluster, just like, and we will just duplicate them automatically, and that's it. Okay, so what to do? We're pretty cool. I would say. So the on-error chain task. The conception is, yes, we can die gracefully, like just ignore the error. But what if I downloaded the file, I tried to do something and I failed, and I want to be sure that this file is deleted? This is the concept of on-error, like event or chain or task or action or whatever. Just like for this job, we are creating the event handler that will run if something bad happens. By the way, this is how the interval chains are created. So just like, yeah. Yep. Graphical user interface, I marked it as done, but I'm not so happy with it. We are working on that. So, and the last is background worker implementation. I'm interested in this, not because we are really need that, you know, just like really hard, but for me, it's the topic itself of creating a background worker in the Go language is very interesting, and I would say this is my pet project. I don't know when we will have time for it. Okay, so we're out of time.
I think we can have 5 more minutes.
Okay, so just like
You just get it guy.
yeah.
By the way.
So this is it looks like when you started, just like from your command line. So you're of course setting the Siemens client name to distinguish each timetable instance from another. Same, by the way, about that. On the database, against the database, only one page timetable instance with the same name can be run. So if I will try to run the same command from another terminal, I will fail because the system will say me, no, we already have a loader in our system and we cannot allow you to have 2 instances with the same name. Why? Because we are doing a lot of these exclusive checks, scheduling checks and whatever, and having several processes with the same name, just like, you know, you cannot control anything. Yeah, so if you are running it, so the first thing, database connection established. Then if it's first time, okay, we are deploying our schema, just like scripts, functions, whatever. Then, okay, we are deployed. We are now accepting asynchronous chains execution, meaning that you can run, execute job number, whatever from your PSQL, and it will catch it and execute it for the backend purposes or for inter-process communication. Then we retrieved scheduled to run on reboot 0. We retrieve interval chains 0. Of course, we retrieve scheduled chains 0. And these, can you see it? So these are the tables in our timetable schema deployed. So we are tracking active sessions. We are, of course, storing the chains. This is the execution log for chain. Yeah, this is the log for the whole session. The migration used for database migration, of course. The parameters, you can put your own parameters to your tasks, just like to whom should I send this email? To this. Run status, meaning are we running now the job number 7? If yes, what the current status is? Can we run another with the same AD, etc., etc. And the tasks, the different tasks, etc. Yeah. So just like adding a sample chain, like download something from from the internet, ignore if we failed, okay. Remove essence, like make it ASCII compatible, then clean table before it, and then import new. We have a lot of samples in the samples folder of our project. One of them is the load. It's just a regular SQL, which when you execute it, it will create the chain and will add 1, 2, 3 steps and will create a special target table if it's not yet created. How we test the chain. So in the ideal world, when we are writing SQL without any errors, we just put the configuration to the server. We start our pgdm tables instance, and we are execute everything great, but not in the real world. Usually, you are checking your jobs one by one, task by task, and then combine it into the one job. That's why we have the concept of asynchronous execution. For example, I have a live PG timetable instance. It's working, it's running, and here I have my editor. I just like make some improvements into my script for job. I just apply it to database, and then I say execute the chain number 8. The pgdm table instance get the message, get the signal from the PostgreSQL server, and grab this new modified chain and execute it. I'm checking the results. If I'm okay, we're fine. If not, I will again make some improvements, run it, check it. So the regular one. Okay. So, for example, here you can see that one of our tests producing 500 jobs simultaneously, and I don't remember what exactly we are testing there. Probably the throughput, but it's okay. It's just like running 500 simultaneous jobs, and they are running smoothly even on the GitHub runner. So we have automatic tests on our GitHub repository, and there we are using the same tests as we do on the local machines. So even on that not diff enough machine, it runs okay. And so just like this is how the output of the pgdm table looks like. So just info, okay, I got information about chain number 12. I'm starting it. At the same time, we are in parallel starting other chains. Okay, I'm chain number 12. I found that task number 14 should be started. Okay, started. Oh, sorry. Then, okay, chain number 12. I executed successfully task number 14, or I failed, then the error message will be here. And all of that is present in the table, so you can group by, find, make some analytical queries against it. Okay, I'm done. Yes, if you want to find this project, it is on the GitHub. And if you have any questions, please.
Do you have functionality to look for dependencies? For example, you have 2 jobs, and you don't know which exactly will finish first or last. But you know that after both of them, you want to execute something.
Thanks for a great question. We consider implementing this functionality in the core, but you can do that on the database level. You can use the advisory log facilities. Just like your first chain, get the advisory log, or your second chain, get another advisory log. And the third chain, trying to get both logs, but it will be waiting until they are released. And that's it. And the reason is that even if the transaction with the one block or another will fail or roll back, advisory lock will disappear and the third chain will go. Just like that.
Because I have a question. Let's say I want to start the job immediately. So I'll just execute some SQL and implement this to the database configuration. And how fast after that this task will be started? Because this timetable process has to check if the configuration changed. So probably it is done every second, I don't know.
Okay. So, thank you for a good question. So how soon our new chain put it into the database will start? Well, that depends on the configuration of the chain itself, because you may say that I want to run it at midnight, right? Or if you put like execute every minute, then the closest time will be less than 1 minute, because PGDN table check the configuration of the database every minute, because the granularity of the cron itself is 1 minute.
Okay, so if I want to do this immediately, the worst case scenario is just it will be started after
If you want to do that immediately, you have a asynchronous mode. You are creating a job, and then you write select timetable dot execute function number of function, and it will be go immediately.
Is it that you should create and then send command to execute? Yes.
Yeah, it may be in the same script. Just like. Thank you.
Thank you.
In the meanwhile, we have really cool news because pizza has arrived.
Perfect timing.
Everyone is warmly welcome to our bar area to have some lunch. And we will have about 30 minutes break, I guess. 30 minutes. Yeah, that's it. So, welcome. Yeah. Okay.
Tak, to Polsce.
Co zrobić? Dobrze. Po prostu kończyć z Krzewskim.
So I really hope you had also a lunch break. Hope you all have your power to go through our next topic, our next talk, together with our next speaker, Michał Małecki. Michał is my colleague here at Polish branch at Cybertech. So far in Poland, there are two of us sitting here, settled in the office, obviously. Michał is a solution and architect designer at Cybertech. Has been working with Postgres for how much? I guess.
First time I've installed Postgres in 1999.
Oh my God.
But I haven't done much with that, but it was really the first time I did, so yeah.
So yeah, Michał is supporting our branch here at Poland at Cybertech since 2020. Yeah, that's just before COVID. That was really fun. And Michał is really passionate about Postgres. He will give us a marvelous talk about the comparison between Postgres and Oracle.
Yeah.
Mostly for Oracle people, but I think
Yeah, since Oracle is so unavoidable, so omnipresent, or at least at some time has been. So
I'll leave the stage for you.
okay.
Enjoy.
So, hello everyone. My name is Michał Małecki. My history of Cybertech was really funny because in 2019 I came to that guy in Milan, and I asked him some stupid question, and no, I'm talking now. and the outcome was that he told me, "Oh, why don't you work with us?" So yes, then I jumped the ship after almost 20 years in corporations and banks and telecoms, and started with a small company doing what I think was very important for me. So the talk is entitled PostgreSQL for Oracle People, but since it is so prevalent, so probably for someone who ever had the experience with Oracle, sharing environment with Oracle, will bring something nice from that. And what's the first and foremost value is the comparison of architectural features and the situation when you are, for example, considering migration from Oracle to Postgres, what to watch out and what kind of habits and expectations not to pass over to Postgres. So, as an I like to start with this really nice quote from Rob Pike, World Programming number 5. Since we are here, I assume that most of you has something to do with data. And as Rob Pike has shown that data dominates. Show me your flow chart and I still don't know what your business is. Show me your data and flow charts are going to become self-evident. So data structures are essential to all the data processing, programming especially. And since we are here talking about databases, data structures will breathe and will eat. And this is really the essence of our services. So, in the introduction, just really quickly, I'm not going to talk about company because Hans already did. If you want to know more, then of course we got the networking at the end of the talk. So we are invited to help yourself with our marketing material, talking with us. First, a few introductions about the subjects of this talk. So me, definitely you. Definitely Oracle and Postgres community in general, because this is important. You cannot think about Postgres without thinking about Postgres community. If you try to do this, you may be frustrated. So, as Anastasia told about me, I am now a solution designer and architect at Cybertech, but for very, very many years, I've been a business analyst and system analyst. So at some point in some big bank, they started to call me architect. I am the one who has a huge diagram with something undecipherable printed on it, and people are shouting at me. Those who want something to do in IT shouting at me, and those who are actually trying to do something in IT because they've been told by the business. I'm always in the middle, so both sides are shouting at me. I've been using Postgres, as Anastasia told me once a moment, since 1999, but it was really a very scratching the surface only. Later then I've been using that in many jobs I've been like trying to merge to banks or trying to implement a new product and cleanse up 100,000 addresses from a big telco whose intention is scrambling and mangling them out. As I've said in 2019, I talked to that guy and he offered me a job. So since that time, I'm in Cybertech. One thing, I am not an Oracle expert, but at some time, very, very old days, I used to be Oracle DBA, and actually in the 1I era. So it was, I don't know, 2000, 2005, this period. Now, what about you? Who are you? What are you doing with Postgres? DBAs or sysadmins, or are you an IT manager, or developer, or a designer? Have you ever touched, or how many lines have you written in PostgreSQL? And again, at what scale do you operate with your data? Not necessarily with Oracle, but with any data you are managing. Is it a one instance of a data storage system, or 30, or 1,000, or what's your scale? Is it just the 5 gigabytes, which is too much, or maybe even less, or 100 terabytes, or even in petabytes? And last question, where your data are living, in the cloud, on premise, or on your smartwatch, or on your phone? Where is it? So if anyone wants to share why they are here and what they are interested in and their personal story, please be invited. I'm not going to call you since we are not so many here, so we can just talk freely and not be constrained by the realities of this presentation. Now, short introduction. Maybe just one question. I would like to raise your hand. How many of you are using Oracle and has been using extensively Oracle at some point in your career? Oh, that's lovely.
Yeah, 10 years DBA or DBA.
Okay, so again,
I'm mainly here because of this.
Oh, okay, that's very nice to hear. Then probably I'm not going to talk too much rubbish. If you find something that you are much more up to date, especially with an Oracle perspective, you are very, very much welcome to just raise your hand and correct me, because as I said, I've been reading Postgres for a long time, but Oracle not so much. So this talk is focused it's not a very typical IT talk because I'm not going to go into very many details. I'm rather trying to provide some sort of perspective why certain things work the way they work in Postgres in comparison to Oracle. So to address some expectations you may already have, your experiences. And if you are going to transfer that experience into Postgres, how to tackle that problem. Because if you are going just to expect something to be replacement, and there is a certain company in the PostgreSQL world, the most dominant one, that's trying to do exactly that. So they are even naming their tooling. So the Oracle admin, Oracle DBA will feel at home. This is not exactly the case. Postgres is a very distinct beast. And to know why it is, and to try to understand this, I'm trying to approach it from some kind of historical perspective. So Oracle started as a product, because the development started earlier, in 1977, already in version 2. Development is a huge organization that rose, closed source, controlled by one and only one company. There are people who have seen the source code of Oracle engine, of Oracle database engine, and it is really something to behold. And I'm not exactly talking this as a compliment to it. Licensing is, shall I say, the most important aspect of Oracle, because it is commercially strictly enforced. There used to be a very nasty proverb that the only growing division of Oracle, the database segment of Oracle Corporation is licensing services.
Yeah, this is the reason that Oracle licensing. The reason why companies that switch to PostgreSQL.
Yes, exactly. And I'm sure that if Hans is going to amend me on that, because he has been selling Postgres to people like Oracle users for a very long time, he has more than one very nice stories about this, how Oracle license audit transgressions and price hikes and changes in license terms has basically screwed huge businesses. And we here in Poland also had situations like that. So there is a free of charge version available, but I shall say that this free of charge should be for the time, because it is also always for the time. It's, by all means, Oracle database, Oracle RDBMS, is not the only product of Oracle that has this licensing caveats. One of those is, for example, Java. If you are working for a company and you're installing Java runtime environment, you should be very, very cautious, because certain parts of that are allowed to be used freely only for private users. If you're a company and you are just check all the checkboxes in Java installer, then you are already out of compliance and they can audit you and bill you. So Oracle and legendary CEO and his, shall I say, approach to money is something to behold. Support is mostly single source. So there's lots of company that's living in the Oracle ecosystem. But if you want a support contract, proper support contract that gives you access to patches, Oracle is the only source for that. So you need to have the software assurance, you need to have their support contract, which costs recently, as I've checked, this was like 30% of the license fee, yearly license fee. What we are talking is on-prem, not cloud, because I don't know anything about cloud pricing, but yesterday when I was just trying to update my knowledge how Oracle structures their products, this was pretty interesting, but I will go to that. So cloud, of course, since Oracle 18, cloud has been a primary target for Oracle. So they are releasing new products in the cloud first, and then on-prem second. Sometimes it's a year, sometimes it's more of a slip between product becoming available in the cloud and then on-prem. Especially this was important at version 21C, because it was a huge departure and huge revolution in Oracle, how Oracle is being built. Like the old lineage of Oracle ended with the Oracle 12C, and then 18C and 19C were like extension of that. Even the internal numbering was reflecting that. Oracle 21C is a departure from that, and it was available basically in the cloud only for quite a long time. So this is the primary platform, of course, Oracle platform. So if you are going to use public cloud provided by any other provider, like Google and Amazon, you're paying basically full price for the on-prem and there is no way to escape that. If you want to have a typical cloud benefits of pricing for Oracle, you must use Oracle Cloud. So I would say it's a bit of an exaggeration, but the platforms Oracle used to work, of course, Linux, of course, Windows. Others more like classic one is AIX, Power 64, so IBM platform. Solaris Spark, which is now being slowly strangled by Oracle, their own product, their own platform, something that in the old times was really a platform to go if you want to have good performance for Oracle, so big boxes Oracle's running on. HPUX, which has been maintained for sometimes as a result of a very nasty lawsuit between Oracle and HP, and ZOS for mainframes. Anything to add to this? I think that's summarize. But just one note. I've gone to the Oracle website and was trying to find where can I download the free version of Oracle, and it was like Oracle Cloud Solutions, Oracle Cloud Products, and then side note, other products. And then was the on-prem DB. So that says something. And it is, I'm not going to deep dive into the financial presentation, but this is the way they are trying to present company. Of course, they are failing. At least their results are showing this. Postgres. So, really long lineage. Very long life. So first version of Postgres, but without SQL. The original so-called Berkeley Postgres was released in 1987. And in current form, it exists as a PostgreSQL in since 1999, when the official Berkeley Postgres project was ended by Michael Stonebreaker, its creator. And then it was just laying dormant. It was open source, but there few guys came and decided, let's do something with that. And they've started in 1999. First, their decision was to call it Postgres 1995. And you remember Windows 1995. It was a vogue at that time to call products that way. And then it was quickly renamed in 1996 into first usable version, PostgreSQL version 6.0. One of the first things to do was to add SQL to that. Development of Postgres is open source, and it is an open source and free software. So it's a very, very liberal license. It's licensed based on BSD, free close license. So basically no copyleft. You can do with the source code what you can. And lots of companies, also Cybertech, has been benefiting from that, because if we want to sell it as a closed source product with our own additions, we can. It's nothing wrong with that. There are a few people doing the global control, so the global core team. We will talk about them in a moment. And what we have here, the Postgres, which is very untypical to other database products, like, for example, MySQL. There is no single company. So it's not owned or underwritten by any single company. There's even a rule within the core team that no more than a number of people from one company can be in the core team. So there is very strongly embedded into the PostgreSQL culture to not allow one company to dominate. That is, no one can buy it out. No one can like cut off you from that. It's always to be there. And the cooperation within PostgreSQL project is pretty significant, even in comparison to other companies. And of course, it does have the side effect that the forks may exist, and even closed source forks, which can be pretty far from the basic Postgres. Like Netezza distributed massively parallel warehousing solution was based on Postgres. Now it is in IBM, but it is still retaining this front-end Postgres. And of course, current offerings of the big public cloud providers in form of managed database. These are also Postgres with some parts replaced and offered with a standard PostgreSQL interface to the customers. Recently, Google has made an announcement that they are providing a PostgreSQL as a managed DB as a service with just storage engine replaced. For support, completely different story than Oracle. You can buy support basically from whoever offering that. Of course, level of professional proficiency may vary, but there are many companies. They are usually focused on some areas. So for global companies, probably there is only but it's also not equally active everywhere. But we do have a fantastic community-based support. And if you still remember, that was something like IRC, the on-internet relay chat, predecessor to any communicator for real-time communication. Postgres community is still very active for PostgreSQL IRC, and basically, if you have any questions, just formulate it precisely and politely, and you will get a first-class answer to your problems on an IRC channel. If this is something that rubs you the wrong way, of course, we are more than welcome to pay for this support for the company side, for example. We do have this very important area of our expertise and our business. We are supporting very big customers and doing it quite successfully. They are happy with us. Platforms. PostgreSQL grown up from the Unix world. So it has been from the get-go designed to work and expect to have facilities offered by Unix type operating systems. That doesn't mean it limits itself. So you can see a huge list of architectures, many of them completely obsolete by now, that Postgres is still able to work on. Because actually hardware requirements for Postgres are very, very minimal in the means of features of the CPU it is running. If the CPU can support spin locks, Postgres can work just fine. Maybe not the most performant way, but yeah. For OSs, mostly stuff that is Unix-based or Unix affiliated, so Linux, but FreeBSD, OpenBSD, all the commercial stuff, not all of them are equally well tested, but most of them are supported. And also we do have Windows, since PostgreSQL 8, as I remember, Windows has been supported natively. Postgres can run fine on Windows. It isn't something that's particularly comparable to the Linux world because of the additional tooling available. But nevertheless, if you are a Microsoft shop and you want to retain the homogeneity of your environment, Windows is still way to go, and companies are also supporting it. Okay, and the last time, this is not the most up-to-date picture, but I think it is the nicest one I was able to find. Unfortunately, our boss wasn't there in Canada, I think. Hans, can you look at you?
I wasn't there.
You were?
Pablo was there, right?
No, it's old one.
Oh, it's old.
It's 1917, 2017.
Yeah, no, it wasn't.
Okay, so so these are the people. You can meet them because the meetup, especially even in Europe, are pretty available and very nice. And really, I invite you, if you have any PostgreSQL events, especially PostgreSQL, Postgres.conf EU, which is the biggest European conference, please join. Many of the core team members are there available and will answer your questions. Also, we have a very nice time. But the team is, those names I'd like you to remember, because they are present on many events. They are giving talks and you can talk with them. These people decide what goes in with every new release. Then we have contributors. So these are people who are responsible for some very important piece of the PostgreSQL code, and ordinary contributors that usually contributing more or less regularly to some features. So as you see, it's around 130 people, and lots of other companies and people who are contributing. There is a page on the PostgreSQL website project. You can see them all by name and by the area of expertise, and most of them are reachable by mail or in their social activities. So you can talk to them if you are interested. Yeah. Okay, any questions till the moment? If not, we are going to the historic part of the speech when we are talking about the lineage of databases and especially relational databases in general. So we are going far, far back in time in the mid-70s. So we are talking about people involved. We are talking in the genealogy of the DBMSs. How this genealogy has been shaped up, and where is the place for Oracle Postgres in that. We are going to discuss quickly a PostgreSQL timeline, so how stuff has developed, and we are going to go quickly through Oracle, major Oracle features, how they've been introduced the time of development of almost 30 years, and how Postgres compares, where stuff has been added to Postgres is comparable, where are the gaps, stuff like this. So before we start, let's talk about those two guys. Ex-CEO, because he stepped down, he is now the chief of, I'm not sure, chief technical officer, Larry Ellison, still at Oracle Corporation, and Professor Michael Stonebreaker, Professor Emeritus at MIT, and currently a technical advisor at Enterprise DB, one of our competitors. I'm sure that since you've been using Oracle, you know Ellison, but how many of you have heard about Stonebreaker? Have you? Well, of course, Pavlo. But this is something that's quite remarkable, and we shall see in a moment why. Of course, this is Ellison. I think that I've tried to get the most important facts of a person in just one sentence here. So in 2020, his net worth is around $93 billion. Google says 99, but I think it fluctuates, and I don't know. The odds are currently quite up or down quickly, you never know. But I also tried to find the most important characteristic of a personal development for such a person. And this is the one for Ellison. So in 77, when he was starting Oracle, then called Relational Systems Incorporated, he was worth like $100,000 to $20,000. And then it has gone up significantly. I was able to get like in 10 years intervals how his net worth was growing. Unfortunately, we still are not at 2027, but as for now, you can see it's accelerating pretty quickly. And considering the way he is doing his business, the way he donates to charity, or rather not, he has one charity. This charity is devoted to extending his life. So it's an institute researching how to extend life of Larry Ellison. It is pretty remarkable. But we have another person on the other side, and those two people actually were quite often interacting between one another in the past, even if not directly. So this is Michael Stonebreaker. And as I would say, his most, like the crown on his very prolific scientific career was the Turing Award in 2014. It's an equivalent of Nobel Prize in IT. So for Stonebreaker and his contribution to relational systems, generally databases in general, it's a remarkable crown. Not many people can say that. And this is how his career, I do not have anything about his net worth, but I think this is much more interesting. And you can see a pattern here. We've got the Ingress project, because this is the academic project, and then after finishing the academic project, you go to commercialize this, usually ending by sale of the company or incorporation of the technology into some other bigger company. So we started with Ingress. It was a relational database, and it was in the time when relational databases generally started to appear. And then RTI was the company. Ingress as a product is still a thing. It's supported by Computer Associates, and you can still buy licenses support for that. Then, after finishing the basic research in relational databases, go on to the Postgres project. This is the Berkeley Postgres project, which current project PostgreSQL is derived from. And then, after finishing that, Postgres was open source, lying around. Illustra was founded to commercialize it. Eventually, Illustra became a part of Informix, and Stonebreaker has become the chief technical officer of Informix for many years. So this was the object relational stuff and extensive related database. Then he had the Mariposa project, which was the federated database. At the early 90s, a thing, and the stuff that was capable of getting some financing after the end of the Cold War. He then created Cohera to commercialize it. Cohera was sold, started streaming database, Aurora, then Streambase. I think Streambase is still available as a product today. Without his personal involvement, but he was the founder. Then the C-Store, columnar database, and created Vertica. Vertica has been incorporated by something in HP, I think. In 26, he founded Morpheus, which is federated data, not data federation, but data integration. So many sources being collated and accumulated in one place. Startup for that was Gobi. Again, year later, simultaneously HStore project and VaultDB. VaultDB is still a product, I don't know with which company, probably IBM, and so on and so forth. Now he is 79. Ellison is 78. So they are like approaching the end of their careers. He is no longer very, very active academically. So he's Professor Emeritus. He does have his doctorate dissertation still promoted, but he is not teaching actively, I think. Sometimes he has public speeches. I will just, if we have time, I will go to many sources because recently, like in pandemics, in the last 3 years, lots of videos and his oral history of his career has appeared online, and it's really, really interesting stuff to talk. He's not the easiest guy to listen to because he's not a great speaker, but so much interesting stuff happening. Okay. And now let's just take a look at how those two people shaped the relational databases world in general. So red bolt is for Ellison, blue bolt is for Stonebreaker. What we see right now, I hope, well, it is very small. If you want, I have the copy, hard copy printed on a big piece of paper so you can, during the integration, bring it. It's more easy to read. But what you can see here is there is something called Hans-Jürgen Institute. It's a German research institution founded by the founder of SAP, and they are devoted to research of database history in general. So not only relational, but mostly. And this is the map they are publishing roughly once in 3 years with updates. So what we have here are all relevant databases, usually relational, usually with SQL, but not only, that existed since early 70s. And let us see what how Ellison has impacted this. So this is the creation in Oracle, 77. And let us see what Stonebreaker has done in his career. So, Ingress, Postgres, Illustra, CStore, Vertica, HStore, Mariposa, and so on and so forth. This guy is basically everywhere. It's 1/5 of the map that he has something to do with. Other stuff that we are seeing here is the PostgreSQL server and its lineage. We've got the Microsoft Access. Well, it's also a relational database. We've got Microsoft SQL Server with its fork from Sybase and then going on its own and sharing some code, even from something that was close to Postgres. We've got like DB2, this green stuff. There are some not very clear annotations, like, for example, here we've got the Bay Area part, because most of the products that are located there has something to do with California and this University of Berkeley, California. So this is their impact. And now how it all happens. So we've got this paper by Edgar Codd, Relational Model of Data for Shard Data Banks. It was published at IBM as an IBM paper in 1970 and completely unnoticed, especially because IBM has very successful non-relational database products with really cash flow for them. And it has been noticed in academia, but hasn't impacted the industry, shall I say, immediately. So from here, 2 paths of development were established. One was internal in IBM, and the other one was founded by Stonebreaker with Ingress. And what we have here, in IBM, we've got a system R. This is the very, very generic ancestor of all SQL IBM products right now. And it was started as a commercial stuff in IBM, strangled by internal wars, so they were not very fast at releasing it. It wasn't full feature, it was like second-class citizen. But they invented SQL. First prototype was done in 1974 and then made available on the platform, a mainframe platform in 79. You see, 79. Oracle was released in 77. And sources were always internal. So despite the academic credentials of Codd, it was just the paper. IBM hasn't been doing any open sharing source with anyone ever. On the other hand, we've got Ingress. It was the first big project of Stonebreaker, and he was saying that it was mostly by accident because he was just young, postgraduate, not knowing what to do, and this was kind of sort of hot topic. It was Cold War, so there were data to be processed, lots of money from military and CIA, so he got in that. And this is something similar with Ellison also, because Ellison started as a CIA consultant before funding Oracle. And the Ingress project, despite being an academic endeavor, was funded by US military, National Science Foundation, and University of Berkeley in California. They've invented something called QUEL. It was a completely different approach to the relational query language. Stonebreaker till this day says that it is much more sensible than SQL. But of course, the original Ingress and Ingress till this day does support QUEL, but nothing else. Prototype was available as a first iteration in 47, so just as Oracle. Commercialization came later, and the platform was the PDP, so it was the running Unix. And what was important, that Ingress was an academic stuff, so it was distributed resources. There was even a Robotron in Democratic Socialist Germany version deployed on their clones. So it was disseminated very, very widely, and like even QUEL wasn't successful, but the mindset and certain concepts from Ingress shaped the world, and lots of people from that project go to the business to establish new companies, like Ingress Incorporated, which later became part of Computer Associates, Britton Lee, Sybase, Informix, Tandem. These are all names that are kind of sort of past, but for many, many decades, they were very important relational databases. Okay, and that stuff in democratic Germany is called DABA. And in this kind of landscape, we've got Oracle. So Oracle was derived from papers in System R. Ellison was to IBM, some kind like Jobs was to Xerox PARC Labs. He has seen the papers, he has seen potential and value in them, and decided we are going to do this quicker than the company that released the paper. So they were able to turn some kind of product faster than originator of the idea. And IBM was fighting inside because they have the MSI and other products running on mainframes. They didn't want competition inside, so they are developing System R slowly. And in the meantime, Ellison released Oracle version 2. In the beginning, there was an Oracle version 1, which was written in an assembly but never released publicly. Ellison funded the development working for CIA on a product named, internal project named, surprisingly, Oracle. Then Oracle was Software Development Labs, very generic name, I shall say. Then Relational System Incorporated in 79, and then Oracle Corporation in 82, so 5 years after releasing the Oracle database. Yeah. Again, the timeline showing Postgres and Oracle here will be, this is the Ingress timeline, and the split to Postgres without actually sharing any code happens somewhere there. And here we've got the Oracle timeline. It's remarkable because it doesn't really have any forks or ingestions. Oracle was developing ideas and stuff internally. They were not like IBM or like Informix or Sybase buying other companies to incorporate their technology inside their core database product. Okay. Just quickly going through the Postgres timeline, we've got the snapshot of the previous slide, and let's go through this. A foundation of Ingress in 73, commercialization in 80, Oracle was at version 2, so the initial version of Oracle, last academic, so the end of project in 84, and Oracle at version 4. Postgres, so the fork of, I would say, the conceptual heir to Ingress. There was no code sharing between Ingress and Postgres Stonebreaker didn't want that. He wanted a clean sheet implementation to address stuff that he didn't like in the original Ingress project. So we are still not having the, we are still not having the SQL here. It's all academic, but they are doing the fork and then the number 5. So this is the Postgres project establishment, and we have the in the long lifetime. Here's when the project ended and the PostgreSQL started. So really, the start of PostgreSQL, as we know here, is 1994. The early approach, Oracle version 7. So first situation when we have like some procedures and like really serious stuff starting to happen in Oracle. And then we are going further, the next release, so the first viable release, PostgreSQL 6, Oracle version 8. And basically then we are going till version 10, which brought the numbering scheme change. I will talk about it in a moment. Oracle was at 12. 11, and since the map doesn't cover most recent years, currently we have the PostgreSQL 14 or 21C. And now just quickly through the lineage. So Oracle based on the system R ideas, PostgreSQL based on own ideas of the from Project Ingress. First release, actual release to the market, so open release at 79 as version 2. Version 2.3 was feature complete. So they, of course, started as fake it till you make it. First activity on community Postgres in 1994. First project version that's usable. So the equivalent to Oracle version 2.3 is version 6 in 1996. First rewrite of Oracle, in 83, Postgres was written in C from the very beginning because it was supposed to run Unix. Transactions, again, written in version 4. Transactional store in Postgres since the very beginning, full MVCC in 1995, so version 6.5. And true serializability in 9.1 in 2011. Client server thing, it was a big thing at that time, going through the terminal systems to client server systems at version 5. Postgres was client server from the very beginning. It's growing up in Oracle version 6. In Postgres, it really started to pick up since 2005. Let's go further. Declarative integrity, PL/SQL, so logic in the database, triggers, and the new cost-based optimizer, because before that was the rule-based optimizer in version 7. Cost-based optimizer in Postgres was since very, very beginning. Genetic query optimization introduced in 6.1, so fairly early. Logic inside database was a little bit later, but very differently optimized. You see on the last slide in the series. Windows port, first Windows port in version 7 of Oracle, but before that there were ports for DOS, there were ports for Windows, but not the NT lineage. Postgres used to run on Windows before, but using the adaptation layer like the porting libraries, but native port was the version 8, it was a big thing, because then we can run natively without any wrappers. Materialized with advanced indexing and partitioning introduced in version 8 of Oracle in 97. Partitioning since version 10, really usable quite recently, I shall say, since version 12 to 13. Still very hot area of Postgres development. Lots of stuff is happening. We are not on par with Oracle, but it's fairly usable if you get partitioning ready. Materialized use in version 9.3. Then the Java craze and internet and Linux port. So everything, this was the version I started with Oracle. Linux was like first-class citizen for Postgres from very beginning. PL Java is available for Postgres, so if you want, you can. You not necessarily should use Java as an embedded logic language, but it is, and it's still available since 2005. Again, new hot topics. So you can see the development now at this time of version 8i. We do have like more or less baseline established, and then various fancy stuff happens in the internet, in the industry, and it gets stuck on and stuck on and stuck on. And we have like the cherry on top in version 21. But we have shared this clustering XML in the database, flashback query. Postgres due to its architecture doesn't have shared this clustering. XML is available and recently has been quite extended to the form that's standard compliant. Temporal queries are not available. It's a huge shame because it's something that I find personally very interesting. But Postgres uses architecture is very well suited. So adding this would be very, very simple on the low level. But unfortunately, last traces, because it was being envisaged as a possible feature in the Berkeley Postgres, last traces called time travel has been removed quite recently. So I don't know if this feature is ever going to be available again. Version 10G was big about self-tuning, self-management. You don't need DBA anymore. Definitely not the thing with Postgres. Although, if you are using database as a service, this is slowly happening. So of course, then you are not able to use it on-prem. But Google or Amazon with Aurora or Google with their stuff is able to somewhat, somehow allow you to have that. I wouldn't say that it's necessarily a very good thing, because then certain knowledge, you are either completely missing it, or by not using it, you are losing it in a way. And of course, since it's an AI, you know, A stands for artificial. So there is not all problems it can solve for you. And essentially using DBA as a service in the cloud, managed database doesn't allow you the full flexibility to decipher and debug edge cases. So, well, there are always benefits and always costs, or sometimes costs are not acceptable. Going further, version 11, Oracle Fusion, Active Data Guard, automatic storage management. For Active Data Guard, we have hot standby, and actually for Postgres, it has been available. You see that the lag is slowing in a way. We are the gap between time gap between both of those systems is becoming shorter and shorter. Storage managed in Storage Manager, because Oracle data files are basically file system within a file. So Oracle is managing it completely as a black box, but it's its own. Postgres, since it has been designed to use as much operating system facilities as possible, has been using this since always. So basically use automatic storage management is for free from the operating system. Compression, consolidation, and online upgrades, Golden Gate in Oracle 11G Release 2. Compression in Postgres has been always in some form in a host. It's not very efficient, but it is there and it has its benefits. Nothing like columnar store in core is possible, but we do have extensions for that with custom storage engines. No online upgrades yet. It might come to some at some point, but definitely not done the way Oracle is doing this. So there are ideas in the community, they will happen, they will be available. Logical replication available since 2017. In a way, if I want to have something comparable to Golden Gate, that's it. In clouds, version 12, multi-tenancy, temporal features, even more pronounced in cloud. Of course, we do have these DBS service basically from the beginning. So first it was MySQL, then cloud offerings for Postgres followed shortly. And this unrealized potential with phased out temporal, last trace of temporal features from Postgres. And multiple databases, despite the very different implementation available in Postgres since inception. Every cluster has as many databases as you want. And the last one is the 11C, again, autonomous database, not such a thing in Postgres, and no in columnar. In version 19, auto-indexing, real-time statistics, SQL on object stores, and in-memory features, and highly partitioned tables. The auto-indexing is not available. We can have extensions that may advise you, but want to create index for you. We have statistics updated automatically by automating, so it is kind of sort of maybe not comparable due to its breadth as the Oracle, but something like that is been happening for Postgres always. We do have partitions with foreign tables in version 9.5, matured in version 10. So something like hybrid partition tables if you use foreign data wrappers and online local storage with flat files, for example. This is possible. And no in-memory features for in-core system. And version 21 came with blockchain tables. We do not have blockchain, and I'm quite proud of this, although adding it wouldn't be such a problem. Oracle is fancying itself. We have multiple languages, so not only PL, SQL, and Java, but also JavaScript. Guess what? Postgres from the beginning allowed for implementation of multiple languages. It was absolutely no-brainer for it, and you'll see why and to what extent it has gone. Binary JSON, again, see, this is 2020, binary JSON, and JSON-B is available since 2014. So now the situation is somewhat switching places. Auto-sharding in memory database and data guard and Golden Gate dedicated to private databases. It is something that's quite contrary to Postgres architecture, so it's difficult to think about it. But if we have data guard, it is cluster-wide, so all databases are being covered. If we have logical replication, it's not database-wide, it's table-wide, so much more granular than that. Okay, and for auto-sharding, we do have something called Citus data. It will allow you, if you got the full commercial license, to have auto-scaling with horizontal sharding and horizontal scaling. This is something nice if you are building something that processes lots of data, kind of data warehousing application, stuff like that.
I think we're
Okay. Okay, 5 to 7 minutes more audio. So, any questions regarding this? Hey. Quickly going through architectural comparison. So, a few things just to have the common ground, vocabulary and changes in naming, how Oracle and PostgreSQL instance in Postgres cluster is done, what's similar, and going through the differences, which are quite substantial. So, Oracle instance is called cluster. Cluster has nothing to do with Postgres with many machines. It's just one. Cluster because you have one set of processes and one shared memory, but many databases with this. Storage unit in Oracle is data file, in Postgres is called data directory, so it's normal directory with discrete files for database objects. Database and database, this is the same. Table space, mostly the same. Schema, also mostly the same, just there is no relation one-to-one between row and the schema. Schema is just a namespace in Postgres. And it is pretty nice because in Postgres, since you do not have synonyms, but you have something called search path, and you can manipulate it ad hoc. So you can have similar stuff named identically in different schema, and just by changing the search order, you can basically cover stuff or replace it. Reader logs in Oracle, write-ahead log in Postgres, rollback segment in Oracle. Nothing like that in Postgres because of difference in implementation of multi-version concurrency. Transaction log, archive log, and archive wall. This works fairly similar. Control files, they are also present in both systems. In Oracle, we have segment. In PostgreSQL, it's called page or block. Page is always 8K and shouldn't be changed. This is a compile time option. In Oracle, without automatic storage management, segment can be tuned depending on what the actual data file is designed to do. So in Postgres, no such tuning necessary. Logic in database, we have packages and stored procedures and functions and classes. In Postgres, it's just function and procedure. This interactive tool you use mostly SQL Plus. Now it's called Web SQL Plus, I think. So you are accessing it through the dedicated web server. PSQL is the command line client of Postgres. We have the roles. both on both sides, and we have the listener, more than one in Oracle. In Postgres, it's just a postmaster, so the master of the PostgreSQL instance. Quickly going through the logical overview, I'm not going to. So we have those components. This is from Stonebreaker Works. So we have the query processor that orders transaction storage manager to retrieve data. We have communication manager that governs, marshals data between the server and users of that data. We have some oversight and additional tooling. Let's just go quickly through the elements. And let's have this map to the physical view. So we have a client as a server connected by network. In this server, we have running database. I'm not using any specific names right now. We have on the servers, there are some local utility programs, and there are some clients using multi-network, some network protocol, and local clients use the same network protocol or different one. In the running database, we have three components: processes, memory, and storage. So memory, volatile, storage, permanent, processes, execution. And then we have stuff in storage. We have certainly some data files on different type. We have some control file which holds the state of the database. We have some configuration, and we have some log files regarding connected with transaction permanency and transactional security. Then we have some set of processes in the system. Processes are just a generic name. It can be threads of execution, something even smaller than threads, pool of threads. So how to use that is very implementation dependent. Then we have memory. We have something that is shared between all processes, and usually some form of buffer cache, and something that's connected with those local and remote clients, so dedicated areas that are holding something dedicated to client session. If it is a thread, then there is just protected by the internal mechanism. If it is a process, then ordinary process protection and memory protection mechanism, at the cost, of course, of going through the system calls to communicate or share memory, are applied. Now, Oracle, this is really outdated. I haven't updated the slide, but should I update it, it will become totally unreadable because it's so much more complicated in Oracle. So we are talking something like 9-10 dedicated server mode. So yes, we have something called Oracle instance, local utility programs, import, export, RMAN, SQL loader, something that's using SQLnet to communicate, SQL Plus, basically something is Oracle call interface, or local SQL Plus. I don't know if Big protocol is still a thing in Oracle. I don't think so. Storage, processes and memory. In storage, data files, control files, init or ISP file. This is something of legacy stuff right now. Reader logs and archived reader logs and rollback segments, which are in data files. Set of processes. So we have DNS listener, which provides admission control, PMON, SMON, checkpointer. These are the core processes, supervising and providing transaction control and storage permanency. DB writer, log writer, archivers, and these are communicating through shared global area with buffer cache, large pool, Java pool, shared pool. These are the most of the memory consumed by Oracle is there. Then we have server processes with dedicated servers. So for one connection, this is one server. If we are running in threaded mode, this is being covered by threads. So there is just a process pool, each spinning up certain thread pool, and queries are being serviced by this. And you can see that there is a private global area which is dedicated for server process, and here the local data to the session are being held. Not so very different in Postgres actually, but with certain twist. So server, no instance, cluster, but if you say instance, everybody is going to know what to do. Local tools, remote tools, server protocol, wire protocol 7, that's how it's called. And local clients using the same protocol, so there is no distinction. It's just all packetized product, just lower version, lower layers protocol can differ. We have storage area called PG data. That's just a dedicated designated directory in the system, processes and memory. Here we just have lots and lots of directories and files. We've got a PG control, PostgreSQL conf, and walls. So right ahead log file. Sets of processes, postmaster, logger, writer, checkpointer, well writer. Those that are in the subtle dotted lines are optional, so they do not have to be present. And we have shard systems, which is shard buffers, wall buffers, C-log buffers, and dedicated one, which contains the data associated with processes. In Postgres, there is no option for threads. So everything is process-based. It is a good and bad thing because they are relatively expensive to maintain, but they provide isolation. Something wrong happens in client process one, it doesn't affect other stuff. So it's very difficult to crash the server that way. And also something that might be quite subtle, you see the proportion between the shared and dedicated. It's quite skewed in Postgres. In Postgres, much more stuff is dedicated. So for example, plants are being logged to the memory of a session. They are not shared amongst sessions, despite their similarity. And one more important thing, operating system cache. As I've said, and I will reiterate in a moment, Postgres relies as much on the operating system as necessary. So here, Oracle takes as much as possible for itself to manage. For operating system, is being used, and operating file system cache is being heavily exploited. And Hans was talking about this during, well, like he was mentioning the synchronous sequential scans. It exploits this feature. Okay. Similarities. Both are ACID compliant. SQL 92 is implemented. More modern versions of SQL are implemented. Postgres is very good at this. Oracle recently too. Quite nice. Intense OLTP can be rightly served, vertically scalable. This is even a bit outdated. I think that it's at least twice as much. Process-oriented, Oracle dedicated server, network enabled, lots of data types available, although in Postgres it is much more than in Oracle. Logic in database is available, very resilient. It's difficult to kill both of them. And replication is available both for failover and home standby for scalability. Now, we've seen the image, we've seen the features. This looks similar. It's not quite because of the differences. So how to approach this? Oracle used to, because it's a huge corporation, they are trying to encompass as much features as possible. So they are all. Postgres also strives to be a part of. So if something is already available, nice caching file system, use it. Pre-existing protocols, use it. Do not reinvent the wheel. The operating system. Because Oracle needs to commercialize very early, and then the hardware was really not capable, they are trying to re-implement as much as possible. It was like 30 platforms they were running on, so really not much common ground. And this heritage is not very strong right now, but still visible. So they were trying to replace as much as possible. That's why they are not using any kind of direct I/O is the way to go, and sometimes to throw partition now automated storage management. In Postgres, completely the opposite. They were not, because they are started as academic program, both in English and in Postgres in Berkeley, they were trying to embrace as much as possible because they haven't got much resources. So, for example, caching blocks for this is primarily an operating system thing. Why use and re-implement buffering when there is already one working quite well, but designed by people who know better? SQL standard. This is changing, and I would say it's changed finally. But at the time I was very much involved in Oracle, there's so many idiosyncrasies that were associated. Simple syntax is available in standard, were not available. Stuff that needs to be done, like the outer joins with custom syntax. And if you are starting from scratch in Oracle these days, you can completely ignore it because Oracle has started up and they are like a good citizen providing a standard compliant interface in the form of SQL. But unfortunately, there's lots of equals to me. And this code needs to be managed. So porting might find issues with that. PostgreSQL, on the other hand, was very much engineering correct. It does have its drawbacks because it slows the adoption of features. Postgres is slow as molasses. Implementing an important stuff can take 4-5 years, and it happens very, very gradually and with great hesitation, not to destabilize. Well, this is the thing with community projects with long histories. Nothing unusual here. And 3 more specific things. First, the MVCC implementation. MVCC is multiple version concurrency, and this is done very differently between Oracle and PostgreSQL. PostgreSQL is the only one on the 2 only databases that are doing this that way. So we basically have copy on write mechanism, and that means that the data on disk can exist in multiple versions in the data files, and the version that are stale, so no longer needed by any transaction, needs to be taken care of. So what it has as a consequence, in Oracle it's quite different. Data are updated in place, and in the rollback original files, there are information how to reconstruct. So if there are 2 transactions and one is started before and want to access data from that has been changed by other transaction, then operating the database kernel must reconstruct the data on the fly. This assumes
actually it's undo.
Sorry,
Undo space dedicated for this.
As I understand, probably it's no more like that, but in the earlier Oracle versions, it was literally 2 versions of SQL, one to change data one way and the other way to change it back. And it was stored there, so it needs to be executed. That has certain consequences. So rollback is relatively costly. Concurrency might be relatively costly, so it's like an optimistic. Data shouldn't be too much in a OLTP system, shouldn't be accessed concurrently if they are changed. Rollbacks are happening rarely because application takes care of error corrections. So if something is committed to the database, it is committed, or something written to the database, it is committed, no problem. In Postgres, it is an MVCC, the cost of an MVCC is immediate. So basically, if you want older versions, so the multi-version concurrency feature is at play, you pay the cost immediately. If you don't use it at all, you pay no cost. In Oracle, in Postgres, it's quite different. So rollback is relatively cheap. And since this is the very generic idea, so you can have rollbacks even in schema changes. Schema changes are transactional. But the price for MVCC is postponed. And then something needs to be done with that. And this is difficult to manage. This is one of the most important stuff to,
Yeah, and this difference is quite noticeable.
some practice. Yeah, would help. I was hoping that my battery was going to last me for the whole talk, but I'm talking too much again.
I had a story in Prague when I was just, I was short and connected, and right in the middle of the presentation, just everything is going. I was like, what's going on? Then Thomas won the game and said, oh, okay, yeah, you put the plug into the socket, but you forget to switch this. Because this was a room in the university and everything turned off, and that eventually if you need it, just turn it off.
South Africa, you purchase electricity in the supermarket.
Into the bag.
No, like a phone voucher. No, with 50 rand, and then you get 6 kilowatts. Later on, you work on it. You can get the kilowatt in the bag.
It's great.
10 times better. It's
They actually have a shutdown schedule. So because they put all the government bodies in this electricity company, they have no electricity, right? Because they need the money to export it to Namibia. So we really have a shutdown. Every day, 3 hours, like with garbage collection. No, they call it blue chip. And they go to the supermarket, use 50 rands, you get a code, like you would have a phone voucher, like you load it up to your electricity account. That's for white people, like what's just finance. So
I'm gonna run out of these questions.
it's not a problem for white people, because the white people.
It's always complicated. Oh dear.
What do you want to start?
Sorry, it's really the first time it behaves like that. I don't know what's happening. How much time do we have? 3 minutes? Okay, it's okay. So I think that I will go just through all those, all 3 features, if I remember them correctly, and just speak to you, because then fighting the machine right now during the talk might not be exactly the best idea. So,
Can I say about something, the last change?
Yeah.
For me, it's, let's say, the biggest change in Postgres and Oracle. Because in Oracle is the space, is under space, so dedicated space for updates and deletes. So the data is stored there, and as far as I know, in PostgreSQL, there's not such space. So when you delete the data from the table, you have the empty spaces, and then you have the vacuum process who just tell the database that, okay, this space will be used because the delete was coming. In Oracle, it's done in different way. I mean, I think it's in better way.
it's not necessarily so, because this is something that it's true that most databases are doing it just the way that we have dedicated under space. And there is PostgreSQL does that with in-place copy on write, SQLite, and Firebase, so interface. They have this implementation, and it's not necessarily that this is better or worse, because usually in most cases vacuum is able to do just fine. However, Postgres quite recently got the situation when you've got pluggable data storage engines. And there is a storage engine called Zheap, which decided to overtake the development from other company, which implements the redo undo exactly the Oracle does. I wouldn't say that every workload that's been natively created in PostgreSQL will benefit from moving to the Oracle type external load. But it's definitely does has benefits, especially if you, for example, consider that the undo can be done that cheaply, and you really don't have to be worried about the cost of it.
Yeah, I noticed in my experience, because when I started venture with PostgreSQL, I have some question about vacuum and basically the space, that is space blocks and stuff like that. So my first thought about that is not to, because there's people just started to complain why there's so much empty space. What's the huge fermentation there, and we have to do this vacuum this vacuum with logs to log the tables and stop the application to do this, to release the space.
But why?
Use speech squeeze.
What?
Use speech squeeze.
There is an online reorg available. You just do have to know that there is it, because in the situation, in fact, actually have the situation with the huge bloat built by some operations, sometimes unavoidable. It can happen. If you are loading and then doing some processing and removing, then any kind of vacuuming, the not most aggressive one, will end up basically in leaving you huge bloated empty spaces. And without, if it is like 1 terabyte table that has been blown to 2 terabytes, then there is no way to painlessly shrink it back with the standard tools. And then you either are using some external tools like we mentioned by Hans, or you need to use very cautious approach to slowly move it away.
I think probably just this.
I'd like to explain quickly how this rework thing works.
Just notice this and check later.
Okay.
Is there a chance to get to?
Yes, I think that we are going to conclusion because with the stuff regarding migration, I think Patrick is going to talk a bit. I can definitely jump in with him, and yeah. So that would be the conclusion.
This tool was developed by someone, right?
Yeah.
Yeah, with the problem,
This is like I'm talking about.
yeah, with the problem with the car maker that a 1 gigabyte table loaded into 3 terabytes or something. Yeah, they are really talented. So the problem is not to do that without taking down the whole factory. So what it does is basically it takes a snapshot of the database it is, writes a new data file, applies logic and key code on that, and doesn't let all existing data change.
Okay. Security stuff. The organization is different. So if you are using private database and pluggable database feature, you have basically dedicated set of roles for each database and only a few very selected global roles in Postgres security information is global to the cluster. So this is one of those non-numerous stuff that's shared by all databases defined on the machine. But otherwise, it's fairly comparable. And for data encryption, which Oracle does have, we do have the data at rest encryption cybertech by PostgreSQL. As far as I understand, there is not such a thing as privilege delegation, so security defining procedures in Oracle. So you need to be able to access all the data procedures able to access. In Postgres, you can use it with the authority of identity of one who has created the procedure, providing additional layer for isolation. Scalability, anything regarding, we do not have rack and real application clusters and automatic sharding and multi-master in the core, but features comparable to DataGuard and Active DataGuard are available. Table partitioning protector, which is not on par, but available. Parallel query processing is available, and horizontal scaling for read-only workloads. And one last thing I want to mention is the logic in database. In Oracle, it was PL SQL based on ADAP, and Java later grafted on, executed by dedicated process, but shared between all the sessions. In PostgreSQL, it is very simplistic implementation and a plethora of languages. So basically, if you have expertise in anything, Python, JavaScript, Perl, Tcl, R, Shell, PHP even, you can have it as an embedded language in Postgres. Performance will vary because it's local to the session, but it is something that's really able to exploit the knowledge you already have. And you do not have to acquire something completely new and foreign to you. And of course, there is the PLPG SQL, which is like the imperative source to the normal Postgres. So here we'll conclude. Patrick, now it's time for.
I think we can make a 5-minute break
Okay.
between the talks, and
Thank you very much.
Don't trust us. Do you have a Zoom link? No? I will send you. So you can connect and we can share my screen. Yeah. Just like. Yes. No, I just see.
Because they will stay Michał, what is
I can see myself.
Just share screen.
Share desktop one. Okay, let me close everything. Yeah.
What's your name? How do you
It's the new one, M1. Back to the old standard. Also, the power supply changed back to the magnetic one. They learned. So, how can I close all of these at once?
Okay.
Hey! With a lag or without any lag?
Yeah, something like 15 seconds. Maybe less.
Terminate.
Sorry about some.
This similar thing is not it's called online definition.
So,
Concepts from TV2 because they really still it's real.
Yeah, but idea is the same. In Oracle, you have the transaction at the top of the database. All transactions are in kind of journal, say, and then there's a copy of database. I mean, the data are transferred to another table, and then at the end you have the very short block on the table.
Switch. The files, yeah. We could do the same. It's, but it still needs a lock, but it's only a couple of milliseconds.
Yeah, yeah.
Switch. It's certainly also tractors. You should tell me because I really not sure. You can have ultimate programming, everything is there. Okay, just two more, just to show. Okay.
Pablo is here. You see the name somewhere? No? Ah, okay. Okay, again. So last but not the least talk, probably the most practical talk today from our Chief Operational Officer, Patrick Thomschitz. I'm not sure about how many years of Postgres experience you have.
How many years?
Yeah.
This year is my first year
Oh, 10.
university.
Anniversary year. Okay. So I don't think we even should describe this talk. It's about migration, easy way. So let's not waste time.
Let's go first.
Okay,
Yeah.
let's skip the first
Slides now. I will talk today about Oracle migration, so the easiest and fastest way from Oracle to Postgres.
So I will skip all the marketing slides. We don't need them.
So, migration. Why should you migrate from Oracle to Postgres? There's only one answer: license cost. Nobody called us in the last couple of years, oh, Oracle is so slow, Postgres is so cool, I want to migrate. No, the question was always, Postgres is for free, and for Oracle we pay a ton of money, and we can do the same thing in Postgres, so can you help us to migrate to get rid of this license cost? So basically, this image describes what the Oracle practice is. If you want to park your car in a huge garage, you don't pay for one parking spot, you pay for every because you could potentially park on every single spot. So that's like if you have 16 cars on your machine and you just want to use 2 cars for your database, you have to license all the 16 cars. It doesn't matter if you use it or not, you have to do it. And that's the real problem these days with virtualization. Or change the license regarding VMware from one page to another one. The whole infrastructure must be licensed, and audits can be very expensive. And the next is scaling up. It's not that easy. Technically, it's not a problem. Just put a second machine, install Oracle on that, connect it through a data guard, and you have 2 instances working on that. But again, you have to license it. So the challenges that we have is how can we get all the data types that we have in Oracle to Postgres. Currently, all the data types that you can use in Oracle are 100% equal to Postgres. For example, varchar 2 is one of them that will not find in Postgres, but we have a replacement for that. It's called hex. Or you set it varchar and then the size you want. Varchar 2 is not an SQL standard or ANSI standard, that's from Oracle, that's Oracle specific. PL SQL code Yeah, Postgres can PL/SQL, Oracle can PL/SQL, but PL/SQL is not PL/SQL, so there are slightly differences. And the people that use PL/SQL and Oracle thinks that DBMS packages, UTL packages, or whatever they use, that's the standard. No, it's not. That's Oracle specific. But we can use it in Postgres. We can convert it to the ANSI standard or to Postgres similar features. And often used NBL sysdate, that's the easy one. NBL will be converted to COASC, and sysdate is current data. So that's the easy things. And the last thing that we do not offer in Postgres are packages. But in the end, packages are just a bunch of procedures and functions, so we can separate it in similar procedures and functions and contain it in one schema. So we have something similar to packages that was Oracle. And the non-technical challenges that we have is downtime. How much time can you afford to migrate your data from Oracle to Postgres? The migration itself, from a perspective from a project manager or anybody in a management position, I heard it very a lot, is just copy the data from Oracle and put it in Postgres. It's not that complex. Copy data. No, you cannot copy the data flash from Oracle, put it in Postgres, and start run. So we have to do really migration data. And the biggest part of the biggest challenge here is how long does it take to copy the data from A to B? And can I afford a downtime, or do we need a near zero downtime migration? So do we need something like CDC implementation? So we capture all the changes in your databases, converting, put it in Postgres, and until we are synchronized, then we do the switch over from one database to another one. And please do not forget about the application. Sometimes the application has raw SQL in it and calls directly DBMS functions, UTL functions from Oracle, or the OM mapper doesn't support Postgres dialect. I never seen one, but it can happen. Migration tools. The most common migration tool, if you want to migrate from Oracle to Postgres, is Oracle-PG. That's the most well-known. The problem I have with Oracle-PG is that when you're starting to using that, it's very hard to get into it. You have one configuration file, and it's very, very unlikely or very, very hard to know what can I do in parallel. What can I do in sequence, and how many configuration files do I need? Is everything done in one configuration file, or do I have to do anything else? It's command line based, and you don't get really much information, just always the same similar basic migrate one database to another one. The second thing was the OR-Migrator. OR-Migrator was invented by us 3 years ago. The OR-Migrator itself relies on the Oracle FDB, so the foreign data wrapper that was introduced by Lawrence Albert, so we can directly connect from Postgres to Oracle and read and write data. And the OR-Migrator does a little bit more for you. It creates new tables, converting the indexes, and take care of your data migration. But again, that's command line based. You need an Oracle instance client installed. You have to compile the Oracle FTP. You have to load it as an extension in your Postgres database. Then you can do the migration afterwards. You have to clean up. Otherwise, you have an Oracle instance client on your database machine that you'll never really use again. And also OR-Migrate and FTW. The next thing that we created was the Cybernetic Migrator, a thing that in the first place should support us for our projects. We have easy installation, one graphical interface, easily go through the migration with the customer. And yeah, as I said, easy installation, graphical interface, so we can click, we can see, we can read the logs, we can perform schema migrations, whole database migrations, or just a couple tables. If we want to select one table from that schema and two tables from that, and we put it together in one new Postgres database. The data migration itself is on sea level in the migrator and in parallel. So we can decide how fast we would like to have it. And after we have one migration example for a queue system or for a testing system already tested, we can copy all our settings from the migrator into a new project and just replace the connections to the prod system. It depends that your testing system and your prod system is structural identical. If there are any differences between your prod and testing system, then it will not work. After the migration, we have an audit or an log file across the whole migration that we did in the migration. We can download it and put it in our Jira desk and say we're done. That's the audit, and if something is missing or maybe misunderstood, we can send it to our manager. New zero downtime migrations will come in soon. We have already in testing mode. We don't deliver it out yet, but we have something called CDC change data capture. So we can directly read from your logs, change everything in Kafka, and then we apply it in the Postgres database. And since we have everything from the beginning on in Docker images, it was an easy step to bring it up into Kubernetes and OpenShift. The data migration itself, we start always with an initial log. Initial log means we need a capturing of all the tables that we want to migrate from Oracle to Postgres with consistent data. So we use the STN number and the flashback technology of Oracle. So we do not say select star from table, we say select star from table as STN number off. So with that technology from Oracle, we have a consistent snapshot of your data, and it doesn't matter if we start the loading right now for the first table and the last table we started in a week. It depends on your management. And
it depends on the answer, because
retention time.
The situation that you do this select and use some SCN and you get error that is
snapshot to all.
Yes, snapshot to all. So you have to use like guarantee undo or something.
They're under retention time, and the undo table space was big enough. That always depends on your database and what you're really doing it. You can have a huge database but no changes in it, and you can have a tiny database but you change the whole data set within minutes. So that's always depending on your use case. Sorry?
What is the reason to migrate from one system?
The reason? License cost.
No, I mean running transactions on the.
The reason is downtime. If you have for example, 10 terabyte database and you want to migrate it and you can afford 5 hours downtime for whatever reason, you have to do a new zero downtime. Otherwise, you may not possible. That's not implemented yet. And partition snapshots means, in worst case, I have to touch the whole database from the beginning every time, because I cannot guarantee that the rows that we captured in the first round with SCN number whatever, they didn't change. I have to check it. Somebody could do an update on that row and change the whole contents of it. So I have to take everything with one STN number from Oracle to Postgres. Otherwise, there are no guarantees. Maybe somebody changed the password of his user in the users table, and we are already in middle in the migration and starting with a snapshot with the latest 1,000 users.
What's then the reason for if you have time lots, we have the same and then we don't know how it happens, when it happens.
Yeah, the problem is there are not really good documentation about untitled spaces from what is inside to get the data or get the information out of it. So Oracle is quite close to source, so we do not know how they store it here, how we can get the information out of it. The only thing that we can use is an initial snapshot, and then we use a log miner for changing all the capture all the changes in the database.
So why do you in most cases they use log miner?
Yeah. Yeah.
Yeah, but even Golden Gate works like that. Provided by Oracle. Okay, this such practice gets this all.
But as far as I know, and I worked just a couple of years with Oracle, I need at least one initial snapshot to know from where I can start to apply the changes. And from there on, yes, I could track all the changes through the log miner somewhere and apply it in patches.
Just turn off the sound.
It is off. It is off. It was off. The mic. Sorry. Yeah.
I had the same problem.
Okay.
Good. Thank you.
So yeah, what we decided, or what our experts decided, is the initial snapshot and then track all the changes through log miner in Kafka. And once the initial data load is done on the Postgres side, we can apply it here. We can apply it from Kafka to Postgres. That's our way of thinking, and I think that's really straightforward. Take everything to time X right now, and all the changes afterwards will be tracked somewhere else. And if we're done with the moving, we apply these changes here. And then we are quite synchronized and can do a switch over of the real migration within a couple of minutes. So the downtime from application perspective is between 2 minutes and let's say a half an hour. The bad side of the change data capture is log miner is for a long time deprecated. Yeah. And we use the feature continuous mine inside of log miner. And the continuous mine feature, the special feature, is as well deprecated, and after 18C, so starting with 19C, this feature is removed by Oracle. Currently, we do not have any workaround for that yet. The only thing that we can offer, and that means, again, license hosts, use Golden Gate. We can easily integrate the Xstream protocol, but to be allowed to use Xstream, you have to have a Golden Gate license, and the Golden Gate license is one of the most expensive ones.
Yeah, the Golden Gate tool is the most expensive.
And then the questions again: is it really worth to migrate it when you have to buy Golden Gate license? Currently, I would say wait a little bit. We will figure it out another way.
Yeah, there's a company I think that's write tool which is able to read the read logs from the scratch. They write this.
That's maybe HDR, or
I don't remember the name. Maybe.
I was in touch with 2 companies, 2 ex-employees from Oracle, 2 coders that was the Golden Gate project, and they started their own companies. And they know how to read the read log binary. Yeah, and that's the thing. It's not.
They're able to share this because maybe they signed something with Oracle. I don't know. It's a
I don't know how they solve that from the legal perspective, but they offer it. So it's not cheap, but not that much expensive than Golden Gate. So yeah, currently for 19C is in developing. We will see what we can offer here. Next slide. Yeah. Migration process. That's the usual migration process. We start in the migrator with setting up the connections to both databases, so the source, the target databases, import the data model in our tool, then we can analyze it, adjust all the data types and sequences and so on what we want. We can also start to clean up something that we say, okay, we do not need anymore this sequence, we do not need this temporary table anymore, so we do not migrate it to Postgres. Then code translation. Code translation means build SQL. Apply the data model to Postgres, starting migrating the data. Then we apply indexes, constraints, and so on. And CDC is optional, and after that we start with testing with the application. That's a thing that we do not offer as a company. We just do it together with our customers, but it must be really, really good tested software that you use on top of your database. There may be some changes in behavior or changes in the application needed that you may not be aware of. And just migrating the database and starting your application, say we are done with the migration, everything will work fine, is the wrong way. You maybe be lucky, but that's not guaranteed. So let me show you a short demo how that migrator works. So let's go back here.
Patrick, you can collapse the Zoom window.
It's a little bit better, but still the resolution is not that good. The migrator itself gives you a short information about CPU usage, memory usage from the Docker container. So we have always our setup designed Oracle database somewhere, our target database Postgres, and in between we have either our Kubernetes plots or one VM where we deploy the migrator. And from there on, we have 4 to 64 cores that we can use for a parallel transfer through the machines. We do not want to deploy the migrator on the same machine as Oracle or Postgres because we have to clean it afterwards. And if we place it on Oracle, you have to buy a license from Oracle to use the migrator. So best way is to put it in the middle on a separate machine.
Can you please zoom out the picture?
Yeah, if the resolution would be a little bit higher, that's normal. Yeah. Is it better?
Yeah.
Okay. Good. Migration. Let's start with the new migration. We have to give them D and names. So one description B1. And the connection string. I've got my connection string. So let me copy that quickly. That's my Oracle system. We need a couple of Oracle rights. So of course, session connect, read any table and read any tables flashback. Otherwise, we will get here an error. We can select which schemas we want to migrate. In that case, we use the HR schema. Then we need all our Postgres instance. So let's switch here to scale field. And then database server tab. Server tag. Let's go. And we will load all the native information. So just describing the tables, fields, everything except of the real data of the database. After that, we get a short summary. Which data types do we use across the whole schema? What we will do in separate stages. So we divided everything through structure, data, integrity, and then the last stage is logic. And when we scroll down, we have here not migrated automatically. Database links are something that we cannot migrate fully automatically. It's not a problem to include Oracle database links in Postgres, but you have to set up it completely manually. Packages is a thing that we have to restructure, and synonyms. Synonyms are basically in Postgres views with select star of the tail that you want. That's a synonym like how it works in Postgres. It's just a different name for a table. In Postgres, we can do the same through a view. On the left side, we have it separated between tables, procedures, views, sequences, and so on. So the easiest approach that I do to test everything is just a shot in the blue. I don't want to migrate the data because I don't want to wait to migrate a terabyte of database data. I just want to ensure that the structure can be applied, the integrity, and the logic. So what I do is just hitting start and wait a couple seconds and see if everything is green or something went wrong. So in that case, all the tables and fields that we have, all the tables that we have could migrated from Postgres. The integrity, the indexing confidence worked also, but we have a problem in the logic. So in the log file here, we see that it failed in the HR at job history. So we have two options right now. Either I exclude that one from the migration because I know I don't need it anymore, or I will rewrite it. So we can click here in the log file to that one and see, okay, that's an Oracle procedure. I have to rewrite it if I want to use it. But I can also say, that's an old thing, we never deleted it, but we do not use it anymore. Let's skip it. So we'll just add the exclusion. The same thing for security ML. And then let's see what happens. So we hit the save button and say resume. So we just start the logic part again, not from the beginning. So we failed again with the view. So that's a normal Oracle Postgres normal SQL view. Create a select from where, and there is it. With read only. With read only doesn't exist in Postgres, so we can remove it, save it, and try again. Resume. And we have one more problem in the trigger. The trigger is in the HR update history. So let's see. There it is. There is it. The trigger is on the employees table, and we use here the add job history. So we cannot exclude the add job history procedure. We have to rewrite it. Let's start here. Create procedure add history. Begin. So what we can do here is SQL as $. So let's save that one here. And we will try to apply it. Here. Then we still have the problem in there. Yeah. We just have only the problem with trigger. Here. Employees, triggers, okay. So now with the trigger, we have to say here, that's correct. That must be performed. And in Postgres, we do not use the double points, old, we use just old or new. And we have it multiple times here. So what I can do, because I'm lazy, I'm really lazy. So let's search for that and replace it with that everywhere. Replace all. Let's save and see how it will do now. The last problem that we have still in the procedure. Oh, yeah. Great procedure. Playing with SQL and Hans, do you see the problem? What did I forget here? Great procedure name, type language SQL as $, begin and $.
What's the error?
I don't see.
Syntax error near insert. Because you should skip begin end. It's just regular SQL.
Yeah, it's just we don't need that. Yeah.
Can I have additional videos?
As many as it fits you.
And now the migration from the structure and from the logic is green, so everything is working. And now we can go back again and say enable the data, because I want to create a new database, and start completely from the beginning. What we're doing right now, if we start here, we drop the schema just to ensure that everything starts from a fresh point. So we apply table structure, the data, after that the integrity to be a little bit faster when we copy the data from over the Postgres, and then the logic part. And right now we are successfully migrated the HR schema. Yeah, it's not that complicated schema.
Those things that cannot be migrated. I mean, database links, procedure, and synonyms.
Yeah.
They are logged here.
Sorry?
They are logged here. I mean, you can see the logs that cannot be.
No, you don't see it here in the logs because they are already excluded in the beginning. So in the logs, you don't get a hint that we didn't migrate your synonyms because we cannot support it. We can place it theoretically in every single log file at the beginning. So all the database links you have, all the synonyms and packages will not be included in this migration. But yeah, it's currently not in that. So what the log file looks like, let's do it a little bit bigger. You get the information from where to where we want to migrate. And we're starting the structure, which tables and sequences are applied on the Postgres side. After that stage, you get always a summary for that stage. So threading from threading are succeeded, no one is failed, no one is remaining. And integrity, and let's go down to the last migration where we have the data part. In the data part, you can extract the STN number that we use for that migration.
And that's.
But there is no.
Synonyms are commonly used basically in Oracle. So it could be a real problem. If they're really used and they're used in the packages, in function procedures.
Yeah.
So all the stuff will be.
We know that our tool is constantly in developing new features to meet all the requirements that we get from our customers. In this demo version, you don't see the hooks right now. We implemented this, was released 2 days ago, the 3.7 version, where we allow after each stage to create a hook with just a SQL file where you can do whatever you want. So if we forget to create a sequence or rename something because I need it and it's not covered here on our left side, so we cannot do it through the tool directly, you can always use one of our hooks and you get just a scratch word and you just have to write SQL code. It will be checked, but the syntax check will start in the target database. So it can fail if you have a typo in it. But with that hooks, you can quite do whatever you want. We had customers, they started to separate the tables, and then in the middle, they said, okay, let's do a copy of the table and rename it because that apartment needed and that apartment, but we want both in the same schema. I cannot have countries in the same schema with the same name. We can countries underscore, or we can use uppercase countries, lowercase countries, snake case countries. That's all what we can use. But I cannot duplicate the countries table in this tool because it's basically a one-to-one migration what we want to fulfill with that tool. But with a hook, I can easily say create table as select star from countries. And it will be done whenever you want after that stage succeed.
Okay, the next question, and there's no scheduler jobs in the list.
Yeah.
Why?
Why?
One thing at a time.
Scheduling. We didn't need it until now to schedule a migration. In the last 2 years, when I started the migration, all the companies set it up, big meetings, middle of the night at 10 p.m. That's the point where we start to migrate. Everybody has to attend and has to look at my screen where I just click on start. That part took maybe roughly 30 seconds for big database. And then we saw this here running, and I said, okay, for the next couple of hours, we will not see really much. We can follow the log file, but we have to migrate 3 terabytes. So we will see the result tomorrow. We can stay in a meeting and watch the log file, the 3 dots, for the next 6 hours until we get a new message. So that's what the companies or our customers normally do. They do not want to do a migration of my prod system tonight at 1 a.m. and do it fully automatically. I believe you can do it. They always want a huge team in a meeting to watch one guy clicking one button. So that's why we didn't implement it yet. We had it in one of our prototypes, but we kicked it out.
Okay, yeah. Fine, but I meant database scheduler.
Oh, okay. Sorry,
Yeah,
wrong direction.
That's fine too because
yeah. It's not in there because I think we have roughly all the features that Oracle offers in the DMS scheduled jobs in PG timetable, but we cannot ensure that you can install PG timetable. So that's why we didn't put it in there yet, because we have to check which extensions do you have installed? Can we use PG timetable? And the next questions maybe will be, can you support these and these and these job scheduler also? And I have to say no, just PG timetable because I have everything under control. And PG timetable will run on cloud systems. Sorry? PG timetable will run on cloud systems.
On anything.
On anything, yeah. So yeah, it's still in development. It's still in development.
At the beginning, you showed the list of the things that won't be migrated, right? And there wasn't DBMS scheduler in jobs. This because you don't have any job in this database, or you have, but this software just doesn't mention this.
That's a good question. That I have to ask Mr. Hofer, our product owner, if it's on this place. Maybe we forgot about that part to mention it at least. But yeah, you're right.
What do you want to know? I can ask you.
The jobs, the Oracle jobs, why we didn't list it in the section not migrated automatically.
We forgot.
I think that's the thing because we didn't follow about the job scheduler.
Yeah.
We use Oracle with our customers types. I don't know, probably more and other cases.
So far, yeah, maybe we was very lucky that we could use that tool for like all the migrations in the last couple 2 years. Why not mention all the things that we cannot migrate? It's still in development, so it's
Honestly, the lack of this synonyms, basically, and jobs.
But the reason for synonyms, we implemented synonyms for a German company, submitted the patch to the Postgres community, and they put it on the list of undesired features because you shouldn't use them because they're evil, whatever, for ideological reasons. So they're explicitly on the list of undesired features.
Yeah, and you have any way to touch all of your packages, at least to go through it, and I think that's the perfect time to set it up in the proper way.
Yeah, I know. Yeah, I know.
Postgres. The next question that I always heard is why you cannot take just the Oracle PostgreSQL and put it in Postgres and execute it like Oracle. I don't care if it's a little bit slower. Do you then start developing Oracle PostgreSQL on a Postgres machine? It's not the right feeling for me. I think a migration is the best time to maybe rethink a couple of processes and restructure.
That is why I was telling that the trying to just have Oracle under different name and cheaper isn't basically the way we are supporting migration. There is one company that tries to do this, but if you ever have seen their prices, they came to very, very reasonable conclusion. But if we are basically trying and doing a pretty good job at offering Oracle based on Postgres under different name, we just charge almost the same prices. And this is eventual effect they came to. There was a story in Poland that they've asked prices that were more expensive than Oracle prices. So,
yeah, but this only you pay for this only once, and then you have like
No,
After you migrate.
you are buying the product and you are basically in the same licensing trend as Oracle because they're licensed, because they want to emulate Oracle as closely as possible. They are also
you're talking
emulating the
about-
Oracle's licensing.
Yeah.
I don't know,
to say-
I thought that you only mentioned about the migration, not the.
No.
the software.
In that case, if you use that specific vendor log Postgres edition,
And they do have synonyms, they do have hits, they do have execution
You
of
can
PLC.
easily do the migration, but you pay the same or more. I
Yes.
don't know the prices. And I see no benefit in it to migrate if I pay the same thing.
Especially that since then you will have to adapt to the way Postgres stores data because they abandoned development of the Oracle-inspired Z-heap storage engine.
Max just answered me why we don't display the jobs, and the answer is because we don't read them from the system catalog yet. It's only to do.
Okay.
Because you cannot translate them anyway. You're using the-
That leads me to the next thing. This tool will be released today, yesterday. I think it is already released in a free version. So everything that you saw right now is the standard version. It's completely free. The only difference to the professional and enterprise version is the CDC part that we've not yet released. So we are hoping that we get more needs from our potential customers who want to use this for real production migration. So we knew which features are really requested, and we knew the priority how we should schedule the development. Yeah. Otherwise, we have a couple of consultants and we have just a couple of customers and we solve just our problems. And sometimes, or especially myself, I get really creative. So if I don't have any job scheduler in the GUI, I can do it on the command line as well. So I don't need it really in the GUI. What I need is 80% should be in the GUI and just the 20% that's not covered, I can do it by myself in the command line. But I don't have to write all the copy statements for 1,000, or we have one customer, 300,000 tables, because I'm lazy. And right now I can click the migrate the data and I have just to do a couple of things manually. So let's go back here. Yeah, the migrator standard version is right now downloadable for free. It's completely free of charge, so you could probably use it for your production system tomorrow or today. And it will be free of charge. And if there are some features that you're missing, please respond to our project, create an issue, and just say, I need that and that and that. Can you implement it? You can directly go on our website and browse through the Cyberlink Migrator or use their QR code. We have also flyers here. And that's it so far. If you have any other questions related to Oracle migrations, please ask.
Updated some functions procedure to make it positive. Is this update was done on the source side or somewhere in
The updates that I did
some metadata level in your local?
it's only in our migrator. It's not changed. We do not change anything or write anything on your source database. We just read your source database. We need the right to write something on the target database, but all the changes that you saw on the screen, so back here, will be stored internally in our Postgres database that is used by the migrator. Share.
Probably another screen. Because you are not sharing. This one.
it worked in the beginning and right now. So all the changes that we do in the tool will be stored in the internal database. Also, if you decide to change one of the data types, or say here, our department name is not null anymore, and we do not want to have it here in integer, we want to have a big int right now. All these information are just stored in our internal database and after we applied it in the target database. And for the code, you always get the original version. So you can always go back and see how did it look in Oracle or in your source database. You can compare it. And you can also download everything and give it to your developers from Git or any other internal workflow. Then you put it again and upload it to our tool.
Yeah, but when you first time you start this, you create this initial copy, right? Then you put your source database and you shut down, let's say frequently, and you close the application. So downtime starts, and then you run this again to just synchronize, right?
Not exactly. So what I do? These stages, the first round, there is no need of any downtime of the application. I do it without any data, just to see if the structure, integrity, and the logic works. Then I started with the data, normally connected to any testing system. So I just need to transfer 10% or 50% of the real data. Then we do the application tests, and after the application tests are successfully, then we connect into the real production Oracle system, and then we run every stage again from the beginning. We apply the structure, then the real data, and with that we have either a downtime for the amount of hours that we expect for this migration, or we start with the CDC. So we have the initial load and start with the CDC at the same time. Otherwise, it will not work.
But how to switch on? Because you didn't show us this CDC. There is some switch to this.
CDC is not implemented yet in the GUI.
Okay.
So what we do, we start the Kafka shortly before we hit here on start, because I have to capture a sequence number lower than the initial load. So I can guarantee I have everything captured after we reach the sequence number with the data loading. So it's a minute before we start Kafka connecting, and if I see Kafka is running and connected, then I hit the start button, we apply the structure, then a couple hours the data, integrity will be started, and logic also, and then on the next morning, normally, or the next day, next business day, we can decide whenever we want to apply the changes that we collected in Kafka to apply it on Postgres. But we have to do it after the data initial load is finished.
Kafka just load probably the read logs on your.
Yeah, through logminer.
Okay.
And through the logminer, we can decide which tables we want to capture. For example, we have one table, not any good table here, but we have one audit table. And that's constantly growing and growing and growing. And everything else is really small. So we can say, okay, let's start with Kafka and just with the login table. So we just migrate the audit table, put it in Postgres, apply Kafka, and when we are synchronized with Oracle, we do the same here, except of the audit table, because all other tables are just 200 megabytes, so it's transferred within seconds. So we separate these in two different migrations. I already did that for one company that had two tables, two audit tables, and they consumed together 5.03 terabyte. So just 30 gigabytes of other stuff, and the rest is audit table. And that was the easiest way for us to migrate it. So yeah, because Kafka has enough resources for that one table, and we do not have to spend it for everything or for every other table. So when we have one or two changes within days, so we can do it in the last snapshot and stuff. Okay, yeah, different ways for different setups, different databases and use cases. No, there is no tuning button in Postgres. Enable tuning. There is no enable magic migration and transfer 1 petabyte in 1 millisecond. And please do also shut down the Oracle afterwards and check the application, rewrite the application, and bring it up on new servers, and please do scale it around the world. There is no magic button. This magic button is called humans. Yes, different use cases needs different solutions. So, unfortunately, no magic button yet. Or you give access to the Chinese government and they will fix it for you because they want the data. They will do the migration for you for free. And you will not notice it. So that could be the magic button. Yes. Thank you. It would be cool if you download the tool. At least try it on some testing system and let you know what you may think is not implemented yet or which things are cool in the tool that would help us and our developers there. Thank you.
Thank you, Patrick, for this really practical talk. And basically, I wanted to say thank you to all my team for coming here to Warsaw and holding this amazing talks about Postgres. And of course, thanks to the attendees for being here, for your donations, supporting Ukraine, supporting Postgres, spreading really valuable knowledge about Postgres. We really hope that you have enjoyed today's workshop. If so, we would be really grateful for your views, for your feedback. You can contact us really everywhere in Facebook, mail, here at the office. It would be really cool if you could leave some reviews on Google, for example, because we really care about that. So yeah, I think that's it. And now we kindly welcome all to proceed to the bar area. We prepared cold beer for you. So yeah, enjoy, take your time, and enjoy.